With this design, there is a slight smell of burnt air, but almost no sense of carbon emissions when putting your nose directly up to the exhaust. The brilliance of Bendel's design is in its simplicity and ability to replicate natural phenomena. Further proof that nature is the most efficient energy machine. This is a plasmoid thunderstorm generator gas engine retrofit and industrial engine retrofit. They are proof of concepts for clean and efficient energy. This retrofit will turn any carbon engine into clean and super efficient oxygen factories, using only gas for the initial start of the engine. For more details on how the Bendel engine works, or how plasmoids are the future of renewable clean energy, subscribe to my TikTok or YouTube channel. I constantly push the bar by introducing you to forbidden and obscure knowledge. Take the red pill and subscribe now. Hello everyone. I'm the Benefactor, and this is Beneficence TV, dedicated to providing you solid entertainment while keeping you informed. We are a progressive media outlet with the focus on providing thought-provoking content on forbidden knowledge regarding topics such as Marxism, plasmoids, zero-point energy, vortex-based math, and anti-gravitics. Our aim is to combat the spread of dangerous misinformation and to educate on these intriguing and unconventional areas of study while separating fact from fiction. Join us on our journey of discovery and challenge conventional thinking here on Beneficence TV.
This video was bang on brilliant stuff. I'll give it a shout out in my next video. I've forwarded it to Malcolm to check out too.
The viewers have spoken.
What an amazing documentary. Thanks for producing it.
Never seen this all tied together so well. Gonna share the heck out of it. Bravo, and thank you.
Divine Science is officially a hit.
Amazing stuff. Very nicely presented. New sub, you can't consume your content quick enough. Great video, dude. Keep at it. We're doing the good work.
You did a great job putting this all together. It's a great overview. Goes into amazing depth at times, so it's interesting for the larger swath of people. Well played, sir.
Okay. So I didn't sleep last night because I watched this 3 times and binged the rest of the channel. You have fantastic instincts for piecing concepts together. Almost every section was something I was already familiar with in a different context. And this documentary was the thread connecting them all.
Join us on a journey into a place of hidden knowledge. A place where science is stranger than fiction.
Introduction, and I think a lot of people here are here today because of this very thing, and we're about to see it in real life, in real time, with the inventor. Now, I know that there is a lot of rumors around Malcolm and his past, but in my personal experience with Malcolm, he is the kindest, most generous, most friendly, and one of the cleverest people I've ever had the privilege to meet, and I can now say he is a friend and a mentor and a colleague, and I am so proud to welcome him to Cosmic Summit. It's Malcolm Bendall!
What I'm going to do today is just introduce you to basically plasmoids, which are also historically known in the Sanskrit text as, this is known as the Vajra here, which is an implosive turbine. We built 10 of these in the world at the moment. And the whole structure of this is male and female, yin and yang. So that's very appropriate for these rooms. The beginning of this adventure was back in 1970 when my high school teacher challenged me about the sacred geometry, and 2 circles with a shared radius is actually the 720 degrees. And so what I downloaded and imagined was if you had a left and a right-hand spiral, which is basically the fundamentals of the universe, and this is what I was trying to get across. And so, and in doing this adventure, all this is about frequency and the resonant frequency of time itself. And to assist in getting the information over, my good colleague Randall is a teacher. Make it very clear I am not. So all my, I attempt to teach, but Randall teaches. So basically,
and I said, well, based on this one image, it looks like these are breaking down ball lightning, and it's the coherent matter that's in the ball lightning that's coming out, and it's able to come back, and it goes to the yang of the yin or the yin of the yang. It's going through, and it because it doesn't have necessarily a charge, but it does interact with gases. You get this luminous thing going through the air. So then what I respect about Malcolm, he's a man in the arena. Whether it turns out to do all of the claims, I don't care. Actually, what I care about is, can this clean the gases in a similar way, at least, to what a catalytic converter does, but just using $30 of steel, let's say, in a way that allows it to be attached to a $1,700 rickshaw in India and to clean up the cities in the subcontinent and in Asia. So if we can achieve that, that would be absolutely fantastic and a credit to the work that Malcolm's done.
Hello, everybody. All right. Today we're going to be trying to develop a new system to test for phase 2 of this 0-point energy generator, which utilizes a Rodin coil, choosing the path of least resistance and both resonance at the same time to produce an over-unity effect. I've been testing this unit for probably 3-4 weeks now. It's given me some interesting results, and now we're ready for phase 2 of testing, but my academic limitations are preventing me from developing a circuit capable of powering the system on a battery. So I've consulted with a few people. Hopefully they join up. If not, we'll get started without them, but I have a whole host of Arduino parts, spare electronic components that we can use to whip something up. I also have an adapter for my laptop that we can use instead of the input on the stereo, which is what has been limiting me from producing the tones necessary to oscillate the DC current into AC current. And that is partly the key to the over-unity effect in the system, is resonating the load with the conductor in such a way that it produces a over-unity effect. Excuse me. I'm going to start the system and just warm it up a little bit. Hey, Mike. How you doing? Pretty good. How you doing, Mike? I hope your day is going good for you. I was hoping to have you on to help me out with my next system. I have a whole bunch of components and stuff that maybe we can whip something up. Yeah, host something, and I'm trying to use as limited resources as possible because I'm using Streamlabs on a crappy computer. So yeah, if you want to host something and then send me a link. Oh, nice. Yeah, definitely. Well, let's use it. Hey, Crypto, good to see ya. Why don't you hop in the chat with us and we'll get started with some developing this phase 2 of testing. Mike's gonna host something, so give him a minute. Yeah, I have a Ryzen. They're amazing. When I get my workstation working again, it's gonna be a lot easier to do this, guys. And I'll get a proper camera, something a little more quality for you. So I don't actually have the coil hooked up to the circuit yet. So this is just the input. We're testing the input, and then we'll test we'll hook up the coil and test the output too. Let it warm up for a little bit. Now with this coil, it's safe to turn everything off when you're hooking anything up, disconnecting anything from it. Even if the tone generator, or even if the power is off and the tone generator is generating, or vice versa, it's just safe to disconnect everything or shut it off. As you can see, I'm hooking up channel A. This is the end of channel A, the black wire. The start of channel A is the red wire here. Remember, channel A and channel B are not connected. Okay. Now we have the end of channel B. And the start of channel B. Oh, okay. Well, I'll be on for a little bit if you want to hop on at some point. I know Mike's going to be... Oh, there's the link. There we go. Just trying to get the shot perfect so anybody joining us can get a good look at the Rodin coil here. Yeah, it's probably gonna cut out a little bit while I'm loading this. It seems to take its time at this point when I'm loading the link to StreamYard, but it's loading, so give it a second. Yeah, it's still loading. Oh, here we go. Yeah, I'm assuming it's because there we go. I'm assuming it's because Streamlabs is using the same resources or the same drivers, so it's hanging up for a minute. But I think it's yeah, it should be loaded now. 1 second. Can you hear me? Hello? Can you hear me?
I hear you.
Oh, there we go. Oh, I'm getting an
Testing.
echo.
I hear you. You there?
Yeah. So, let me show you what I got to work with.
Heard you there for a second.
Can you hear me now? Hello? Can you hear me?
Nothing now. I hear you.
Oh, there we go. Oh, I'm getting an echo. That's coming from your stream. Your remember StreamYard? I think you had to mute it last time. Yeah. So, let me show you
Testing.
what I got to work with.
Heard you there for a second. See, maybe it's me.
Can you hear me now? Hello? Can you hear me?
Nothing now. I hear you.
Oh, there we go. Oh, I'm getting an echo. That's coming from your stream. Your
Say something?
remember StreamYard? I think you had to mute it last time. Yeah. So
Actually, you had it right. It was me a second ago. StreamYard keeps.
Oh, okay. Well, I'm still getting an echo. I think the stream that you're playing in the.
Oh, let me mute that. Hold on.
Yeah.
There you go.
Okay. All right. We're good now.
I found something you might.
So I have 2 of these giant Arduino kits, along with some batteries and some other components that we might be able to build something for phase 2.
Where is this? Ah.
I've got a bunch of potentiometers, different ratings, resistance ratings, and some switches. Oh. I took this DC battery pack from the Arduino kit, and I cut off the tip because it's meant to be plugged into the Arduino, and I just rigged it up with the jumper cables so that we could just plug it right into the breadboard.
Where's that here? Hold on. There you go. You see that?
Yeah, you sent me that. That's a good idea you had, drawing up the connections. I think okay, yeah, I'll shut you off. Along with color coordinating them.
So we can do that. You want just open it in the photo editor right here.
Mm-hmm.
And I believe it's 6 wires on each end, right?
So I have 4 leads coming out.
Okay. On each end?
No, total.
Okay, so you can do 2 on each end.
Yes.
All right, I'm just scarfing down a little bit of food here.
No,
Give me about 3 more minutes.
I am.
And I'm going to load up the editor, and we'll do that.
Yeah, I'm trying to get my electrical components in order because I'd like to. I did briefly hook up the laptop to the breadboard with the battery pack, but I wasn't able to actually get it to power anything through the coil, and I'm wondering if I had it configured wrong.
Usually, when you send power to the coil, the only way you're going to get that power back is by flipping the polarity on your receiving end of the battery. Or you use the power by generating a magnetic field with the coil to drive a wheel and use the power. But you can also put the coil on a transformer and
you know, transmit it.
I had a what was it? A 12-volt fan hooked up. I didn't try the lower voltage fan. Maybe I should have. But
A DC fan?
yeah. Yeah, it was hooked up to a
So you need, oh yeah, the only way to get the power out of that fan, because they're not built to select it's called the flyback, the reverse polarity flyback. Those, nothing they build is designed to capture
Well,
that.
I had it fed through a rectifier with a capacitor. But I'm wondering if I had the configuration, because what I did was I put the battery on the power rail, and then I put the tone generator input on the power rail. Is that how you how you would properly combine the two?
So let's say you got a coil, you're charging it up, left side of the coil with plus and right side of the coil with minus to run the fan, right? And yeah, the fan is a way of harnessing that energy you're putting in the coil by spinning it. But if you want to get the flyback that happens on that coil during each DC pulse on that fan, you need to hook up a high voltage flyback diode pointing away from the connection of the coil where you gave it a positive.
Oh, okay. So
and tie that diode to the
use,
positive of a battery.
So I can't just use the standard.
And then the other end of the coil goes to the negative of that same battery.
So what you're saying is I can't use the standard diodes that I have been using for my my rectifier circuit.
Give me a second.
For those who are joining us, we are running the 0-point energy system. It is utilizing a Rodin coil, and as you can see, it is spinning this fan on the output and lighting the LEDs, and the input is not even spinning the fan. It's it's barely spinning the fan, and it's barely lighting the LEDs. So actually, if we turn this down a little bit, it'll stop on this side. There we go. So yeah, this is not even powered at all, and this is being powered right now, all through the geometry and resonance of the coil.
Oh, really? You mean that coil's not receiving any signal?
No, it is, but I'm saying
amplifier.
The input isn't. The input isn't being fed through the coil, just showing the input power.
You mean the amplifier signal?
Right.
The stereo.
Right, and
And the coil's putting out a small amount of voltage.
Yeah, it seems to be doubling the voltage. What's it at right now?
Enough to run a small tiny fan.
Yeah, and see, that's the thing. It's getting enough efficiency for me to test it with a battery, and I don't know how to roll that out at this point, but I'm hoping that I'll have that figured out soon. So we have 2.3 volts on the input, and we have 3.9 on the output, utilizing 1K hertz frequency.
.9.
So we have 500 milliamps on the output.
500 milliamps on a 3.9 volt. What is that?
So let's take a look at the input current.
It's like 2 watts on the output.
0.259, so that's 260 milliamps on the input. 260
With
on the
3.
input.
with 3.9 volts on the input?
2.3 volts on the input with
2.3.
260 milliamps.
That's 0.59 watts in and about 2 watts out. You said 3.9 on the output.
Yeah. Like I said,
That-
different frequencies, it might give you a little bit more.
Yeah, you're getting like 1.5 more.
Yeah, about 155% efficiency or whatever the calculations I did a few days ago.
Hey, Lulu.
Hi.
Hey.
Hi.
Nice of
Phase
you to
2,
join us.
experiment. The live demo.
You said what?
So
I said phase 2 of the experiment, the live demo.
Yes, phase 2 is rolling out, and I'm hoping that we can start testing it on a battery soon. So that's going to be really exciting.
Does it have to be, can it be a car battery?
Yes, any kind of battery that you guys would recommend, because I'm not the expert here. I'm an expert.
Does it have to be a good battery?
I'm sorry, come again?
Does it have to be a good battery, like one that was changed from, was replaced in a car?
The output's 3.9 volts. So
yeah, I don't think it matters.
Okay. I have 2 of them.
2-volt battery. A 2-volt battery would be a good one to do that on. They have 2-volt batteries. They're big though. They cost a lot of money. You might be able to find a small one somewhere. Your audio cut out, Ben.
Did my
No, there you go. You're back again. Maybe it's a cable. So yeah, they have 2-volt batteries for like, solar panel backup systems and all that kind of stuff. And marine grade, 2-volt batteries for the backup power for boats, but they're expensive and they're battery that's small. You can do that test with. That'd be better because you're putting out 3.9 volts, and you need at least more than 1 volt of your over the battery you're trying to charge.
Interesting. I didn't.
Like 1.5 volt, 2 volts even.
So do you think we could do anything with this little 9-volt battery?
It's 9 volts. You'll never get over 3.9 volts on your source to reach 9 volts. So the 9-volt battery won't charge. It won't, go to 9. Unless you get a 9-volt battery that's below 3.9 volts. Let's say it's a dead one, like 2 volts, holding 2 volts. You bring it up to 3.9 volts.
What about
your audio keeps coming in and out?
What about?
No, you're back again.
It must be because I'm far away from the mic. It's a very sensitive mic. So what about trying to just power a simple like DC fan with it and seeing how much we get on the output versus the input? Would that be possible?
What I would do, what I'm heading towards doing with the low voltage that comes off of these devices is your audio is going again.
I'm not saying anything.
There you go. You're like in and out.
It might be.
Or maybe it's the lag of the video. Never mind. The video's lagging. Sorry. I'm sharing your.
Oh, okay. Yeah, no, it might be the video or it might be my connection.
Disregard it. Your audio's fine.
Okay.
Like you're getting low voltage, so if you want to bring that voltage up, you want to do what a buck boost does. It basically sends that voltage into a coil with a switch and then disconnects it and lets it fly back with high voltage. And that way you can boost up your voltage and charge just about any battery, any voltage rated battery. That's, yeah. So like you take that 3.9 volts and send it into a small coil with a switch, pulse it into a small coil, and then take a high voltage diode in reverse polarity on that coil and feed the flyback that it creates into the battery that you want to charge.
Okay, and you're recommending a little bit bigger of a battery, like a small car battery or maybe like a electric scooter battery?
Well, because you're only getting 3.9 volts right now. If you put any battery that's over 3.9 volts, it won't get charged. Unless you put a 12 volt, it won't reach 12 volts because you're only giving it 3.9. That's your pressure. You can't pressurize a 12 volt battery up to a 12 volt pressure rating.
So in this scenario,
you only
are
have
we?
3.9.
So in this scenario, are we just charging the battery off of itself?
Well, you're getting 3.9 out of the coil, right? Volts?
Yes. Yeah, we're getting double voltage while maintaining the current or slightly increasing.
Right, but your source is not coming from a battery unless you make it that way, right?
Correct.
So, do you want to continue to feed it the 2 volts that it was being fed with this battery?
So right now, my goal is to just develop a test that can test the input versus the output. In any way.
You know, technically speaking, technically speaking, the coil seems to be stepping up the voltage on the output from the input. So whatever input voltage you're giving it, the output should be a little bit higher than the input voltage. So you're correct. You should be able to channel it back.
Okay, so that might be the easiest.
So if you
way
give
to
it,
do this.
yeah, take the stereo away and just give it a pulsed 9 volt DC signal from a 9 volt battery.
And
would
I be able to hook that up on a breadboard or?
Yeah, you need a transistor or like a relay of some kind or something to turn, disconnect and reconnect that 9 volt battery to your PoE coil at the whatever frequency you want.
So I'm gonna need help with that circuit.
Yeah, I'll help you with that. The Adreno will control a relay.
Okay.
A standard car relay. You can control that with an Adreno or a function generator signal. You can also control the transistor with the same Adreno. So yeah, when you're ready with that, I can help you.
Sure. Yeah, I'll get the materials required, which is basically the battery. That's all I need right now, and that will be exciting to test for sure.
I think it'd be easier to start with a standard relay than a transistor, unless you want to just use a transistor. And you just use a transistor and Adreno. That way you can reach higher frequencies.
Yeah, we definitely don't want to limit ourselves on the frequency range, just because this does operate at higher frequencies than typical systems, and also I want to leave a little wiggle room, just because I have the laptop connection now, so I can output a little bit higher frequencies than I could with the app that I have for the stereo. I think it only goes up to 20 kilohertz, which
it's another thought. The stereo, let's say, it's putting out under 5 volts, right? The stereo.
Yes. Let's see.
Okay, so did you know that a transistor gets triggered with less than 5 volts? If you go over 5 volts, you burn it out, or you blow the base emitter junction. The base is where you send the positive less than 5 volt signal.
Right, there's three connectors on the transistor, right?
Right. The collector and the emitter are just like a switch on the wall. They're just connecting the positive and the negative. Let me do something here. Hold on.
No, you're good. So let me update everybody. If you guys are just joining us, we are trying to develop phase 2 testing of this Rodin coil, which appears to be putting out at least about 55% more energy than it's taking in at its peak resonance. There's a range, so when you tune into that resonance, you can get a little bit more or less efficiency. I try to tune it down a little bit, especially when I have to monitor the current so I don't blow my fuse in my multimeter. But right now we're just trying to determine what our next step is in taking this and operating it off a battery and then testing it and seeing the results that way.
So you're going to create.
See the screen?
You're going to create a relay of it.
I guess that's his idea. I honestly, I don't understand relays. too much. So if you want to like go and like a basic breakdown of what a relay is.
Can you guys see the screen?
It, just like looping it over and over and over and over and over, you know.
Oh. Okay, so
But-
it's like almost like a reverberation of a sound. How it's just like echoing over and over.
I mean, this
Ben,
is
can
my
you see-
my understanding of relay. You know how CERN has their collider, their round particle collider. Well, you know, I would assume the relay gives it the thrust energy. Like it goes like, I don't know how to explain it, but it gives it a boost. You know, and at least that's my understanding.
Maybe it's like increasing the electrostatic pressure or something.
Yeah, again, I believe so.
Can you guys see the
This is the coil.
image on the screen?
Yeah, that's a coil winding, right?
Yeah.
Yes, that looks.
So this is the Rodin coil he's working with.
Yeah, that looks to be like a Rodin
And,
coil, same design as mine.
I saw that the other day. Somebody it was inlaid in epoxy. I thought it was the coolest thing.
So yeah, there's gonna be
And then
2
you
start
have,
and 2 finish, 1 from each channel.
It's like this, right? Right? Am I getting this right?
Almost. So you want to separate.
Hold on, I'm
actually,
not
yeah,
done.
they're
I'm not done. I'm not
twisted.
done.
Okay, yeah, so that's right. Sorry, it's really
I know.
small. But yeah, that's right.
I'm
but
just trying to simulate the twist.
No, you're good. I'm just my eyesight's bad. So on either end, the audience can't see this. Like, maybe I can bring it up.
Well, I'll bring it up. When you're ready, I'll bring it up on my stream. So
Okay. So
bring it up on
anyways,
your stream. Well, when you bring it up on your stream, it'll show up anyway, but I gotta load the window. So there you go. That's 2 strands, 4 ends. Bifilar. All right, there you go. That's
okay.
2 strands, 4 ends. Bifilar. I'm going to draw the stereo out.
Let's see if I can get it. It's not. Oh, it disappeared on there. Okay, never mind.
So each cross,
All right, there you go. That's
Okay.
right? Each crossing is 2
2
strands.
strands, 4 ends.
Okay.
Bifilar.
So basically, we're just fixing
draw
up a
stereo, yeah.
diagram that we can put into the Rodin coil guide that I whipped up. And what you're gonna do is, it's easier to color
So each
coordinate them.
All right,
You-
there you go.
And channel A is
Yeah.
red
Right?
and black.
Each crossing is 2 strands.
Gotcha. 4 ends. Give me a
Channel
second.
A and channel B
do it.
have 1 start, 1 finish. We're just fixing. We got a diagram echo. That we put in the Rodin coil guide that I whipped up, and what you're.
There you go.
So I guess the start will have a red and a yellow wire, and the finish will have a green and a black wire. Just to make it a little easier to visualize when you're building your coils and connecting them. I mean, you could really use any colors you like. I just, that's just what I had.
Okay. Red and black, right?
Yes. Yes, red and black. for channel A.
I'm getting good at this StreamYard stuff. So you can see the image on the screen? And red.
Oh, there we go. And I can bring that up for our audience now. I believe. There we go. Okay. So everybody can see what my friend Mike is working on. He's graciously offered, him and Lulu have graciously offered to help me with phase 2 testing. So if we look at my coil, it has 2 channels, channel A, which is the input channel, and channel B, which is the output channel. This is our output circuit to demonstrate the output voltage and current. We also have a multimeter. I was demonstrating that earlier, that we're achieving about 55% more energy out than in right now. And I've been monitoring the temperature. It has only increased about 1 degree from ambient. This is our input circuit, again used to demonstrate how much power is going into the coil, which is, you can see the fan's not spinning, the lights are barely on. I can show you a closer look in a little bit. And obviously this one is spinning like crazy. Lights are pretty bright. Oh, give me 1 second.
That to here. Why isn't it coloring in there? Oh, color's in there. Let me see.
What are you trying to do?
Show the wiring of this coil.
You want to color code it?
All the connections and yeah. So it shows like.
Kind of hard to see though. Yeah, like if you zoom in, then yeah, you can see them.
Oh. How about now? Or is that better?
I mean, I'm zooming in so I could see it, but I don't know for YouTube if like can they zoom into the screen? On StreamYard, you can zoom into the screen to see, you know, up close whatever is up.
So there, that's as big as I can get it there. So And the wiring is the question here is the wiring. So the stereo has a output in the back of it. There plus and minus. I believe it's two of them, two outputs. And
So if you look at the guide, I do have a picture of the output. It is it's actually four, one for left, one for right, and one for left back, one for left right back. But we don't really need to show that. It's really important that we simplify this as much as possible.
is that looking correct or?
So hold on one second. So it's only two wires going from the stereo. You can just take out that extra red one on the right, and then reattach the red. Reattach it to the right next to the black one on the left. So you have one start in the red. The red start is going in, and the black finish is going in.
So talk to me with the right side, the red and the black.
Okay, so black is going in to the stereo.
Here?
Yes. Yep. And then from the start side, which is the other side, you're going to do the same thing for the red and just put the red right next to it.
This right here?
Yes. So you have one start
Goes
and one finish.
here?
Yep.
Okay.
Yes, and that is how it's hooked up. And then you have the two output leads, one red and one black, or whatever color you want them. I have green and yellow.
The two output leads. So you have a red output on this side. I see. On the right side, you have a red here.
So actually, technically, that one is green for me, but it's still going to be black. They're both going to be black on the output. Or if you can make it green, it really doesn't matter either or, but it might be less confusing to make it black. Or, I don't know, would it be less confusing to make it green?
It doesn't matter, black or green. We use either or. They represent the same common.
Okay.
Black can be used as sometimes in low voltage, it's used as a common. I mean, it is actually. Red is the positive.
Right.
And black is the negative. So off this right side arm, you have the positive here.
No, they're both negative on the ends.
On the right side?
Yes. So the left side is the start. That's what I refer to as the start, where the energy is going in, or the start of the.
Oh.
Well, a lot of people refer to the start as just the start of the winding pattern, also, and then the right side.
But you
is
have
the
four
end.
ends on this coil. You have two pairs, four ends.
Right. Exactly. But that's a little confusing when you're referring to the start and the end of the wind, because I have two on the start and two on the finish of the actual wind pattern, if that makes any sense from that perspective.
Is it connected? What are we missing on the right here? We're missing one wire here on the right side.
Yeah, so just two black and two red.
Make them two blacks. Okay.
Yeah, so they have to be the
And
same
the left
color.
is two reds. Two
Mhm.
reds. Gotcha.
And then those
No
empty ones will be
problem.
our output for our load.
Hold on.
And just a reminder, we're using the closed circuit method, not the open circuit method, which is the Nunez method.
So the other black goes to the other negative on the other channel of the stereo?
No, so you leave
correct?
two open. You leave two open for the load.
Two open?
Yes.
Oh.
Yep.
Right. That makes sense.
Yeah, so now you're
There's
painting.
your,
It's hard to understand when you don't have it in front of you, but I think you're starting to paint a picture, and it's I know these setups can get a little confusing.
So what happens to the other wires that are loose? The one that he's right now drawing circles on.
So you attach those to
That's
whatever
your
you want
load.
to power. Yeah, your load. The stereo basically acts as a tone generator and a battery, a power source, and allows you to. It's a very clever way of getting a cheap waveform generator and workbench power supply, because it allows you to adjust the gain, the volume level. Like, I have to say, this setup that Daniel and Erica Nunez provided for us is very clever and very efficient, not only in its design, but in saving money in your wallet.
A self-sufficient power generator. It's really cool.
Yeah. I mean, it's this is how Randy Powell describes it, and he's the one who actually took Marco Rodin's vortex math theory and applied it to the coil for practical applications. Daniel Nunez and Erica Nunez kind of developed it further than that, but and his words are, "It is a system unaffected by the weight that it carries." I think that's the most elegant way to put it.
I have a question. What if you were to put the coil on one of those like little things that give it different degrees of motion, like freedom, degrees of freedom, like each component, if you put it on its own, I think maybe they call it balancing beam or like think of a sphere with many circles in it, but some of them have freedom of motion, so it's not stable. Look, because all of this is on a flat surface.
Mm-hmm.
But what if you were to put them, attached to, say, let's to the ceiling on rubber bands, like
Are you talking about like cymatics?
Yeah, no, I'm talking like in free space, but give it like the X degree of freedom. You understand? Like if you plot this on the X and Y's, you like an X and a Y wave function. But if you give it a rotation, like the freedom of let's say it can go forward, backward, like at least in space, like a gyroscope.
Okay.
Like, what if it moves? Then it's giving forward thrust.
You're talking about the coil itself.
Yeah, the coil and the stereo, because it still has to be, like, so the energy, the wave energy from both, there's coherence between them.
I've heard people say that the coil or any Rodin coil has the ability to levitate. I'm not sure how. Do what?
That way you could see it, visually you could.
I thought about doing like a cheap weight test, putting it on a scale and seeing if anything happens at different frequencies. But yeah, that's an interesting idea. I'd like, like that. I'll add that to the list of things to look for. I'm not quite sure I understand the setup completely. You might have to describe it a little more in more detail at some point if we do that test. But yeah, I'd like to
No,
do something like that.
I could do it now. I'm like, all right, let me show you something. Let me get some supplies. So, all right.
Science.
Okay, you see this little thing? You see this little thing?
Oh, hold on.
Okay.
Let me make sure the audience can see you too. Give me 1 second. Oh yeah, they can see you.
Okay. All right. I, take this stuff out and put another one in from here, a smaller one in, and hang it up through here. It will give it a degree of freedom, because now it's rotating. Like it on the inside, it could go. So
Yeah, so you
like
can
build
see
it.
if it's has any fluctuations in the air.
Yes.
Wow.
So, and you connect this to a rubber band, up to the ceiling, so you could see if there's a bounce to it.
And I have a really small room, so if I turn off the AC unit, it'll be pretty still in here. So yeah, that'll be pretty cool test. I'll have to get one of those from like the dollar store or something.
Yeah, they're like simple decoration things, but they have a really nifty shape that you could build upon.
Right, yeah. That kind of plays on a little idea I had of putting streams on the fan so people can kind of see the fan a little better on this crappy camera. But that's a really good idea. Thank you.
Yeah. Sure.
Crypto says Lulu has some awesome ideas. Yes, she does. You all do. In Crypto, it has a really cool setup with his electrochemistry, which is something that I admit I know nothing about, but I'm really excited to learn more about it. And I know he's working on, I believe, carbon nanotubes, which is also an area that I'm unfamiliar with. That's more of like material science. But anyways, we have a whole bunch of really smart people here to help with this project, and I'm very grateful.
Bernie is tries to synthesize monatomic gold. Yeah.
Oh, hence the name Alchemist. I love it.
Yeah.
That's pretty cool. All right, I know I was mentioning the Nunez method earlier, and I'm going to put this up on screen so everybody can just see the circuit here. It's an open circuit, and that allows the resonance to, I guess, resonate more.
So the free ends from the stereo, what do you attach those to? What could you attach those to, and what can you power something else?
I am glad you asked. So right now, we have 4 channels for the stereo. Okay, two terminals each, one positive, one negative. So technically, we have 8 terminals, pairs. Right now, I have the one extra speaker terminal, positive, negative, hooked up to this input circuit, demonstrating the input output. But if you had, hypothetically, and I've actually tried this with this coil because I have 2 channels. But if you have 2 channels or more, you can hypothetically put multiple tones in, multiple frequencies, and see what happens then. And I'm very interested in doing something like that too in the near future. Yes, and that reminds me of another idea, Crypto, is I want to plug in my, I want to input my guitar into this thing and jam out and see how it sounds. It probably won't sound as good as I think, but if I get maybe a parabola, a proper parabola metal shaped one, maybe the sound might be good. It supposedly has high quality sound when you make the coil right and you hook it up right. So we'll see. Yes, multiple tones will be interesting to test with, because it's my theory that you will need multiple tones, at least 2 or 3, to produce any kind of levitation effect. And my ongoing theory, and this is just a hypothesis, is that you will need 2 tones of the same and 1 of the opposite. So kind of like how you see that reflected in Marco Rodin's Vortex in Math to access the 0 point 369. You always have to have, and it's a palindrome where 3, 9, and 6. 3 and 6 are on the opposite of 9, and 3 and 6 fluctuate back and forth. And while 3 and 6 are positive, 9 is negative, and the opposing is true as well. So I'm thinking there's some kind of asymmetrical factor in play there, and that's just an untested hypothesis. But for sure, that would be cool to see.
Like a group amplitude or group velocity.
Yeah, I'm assuming that has something to do with like harmonics.
Mike knows about harmonics a lot.
Resonance, resonance, you take a glass, a crystal glass or a regular glass, you put it on the table or whatever, a surface, you beam a sound wave at it until you change the frequencies till you reach the wave that makes the glass vibrate. Then you're in resonance with the glass. As long as the amplitude of that frequency is below the amplitude that the glass can handle, it will continue to shake perpetually without breaking at that frequency. That's the only reason why the glass breaks in those videos, because they're turning the volume up at the same frequency. They're just turning the volume up, the amplitude.
Right, the gain.
Right, and they turn it up too loud and it breaks, but otherwise it would just continue, the glass would continue to vibrate. It won't break.
Huh. That's fascinating.
I don't think it will anyway. I mean, because you're not over the threshold of the amplitude of what the glass can handle. Now the glass has a shape, right? It has a particular shape. That geometry correlates to the frequency.
Mm-hmm.
No, the shape of the glass. The cavity too. Yeah, right. But that all turns into a specific frequency.
Right. Okay. Yeah, you're talking about the shape in entirety. Yeah, the handle and the.
Right. So you change the shape of the glass. Now your frequency to get that shape to vibrate is going to have to be a different frequency, because each frequency is resonant with each individual shape, and I don't think there is a limit to the shapes that they're either.
So Crypto says you need 3 coils to create a free energy system dynamic, with the 3 stacked on top of each other, the middle coil attached to the grid, but the top and bottom coils are not. That is absolutely fascinating, and that would probably be a great idea, specifically because the stacking them on top of each other will produce a pickup effect and amplify each other, but they're not directly connected. Like, Daniel Nunes says, if you directly connect the coils and resonate them, the first one will destroy the second one. But if you stack them on top of each other and separate them like that might work.
It creates amplification.
Right. Yeah, because they're pickups. They act as Tesla coils. So when you have one coil on top of the other, you can power a load without the second just sitting on top of the primary coil. Nothing attached, no wires, just a little LED. Which is how I think this thing is inducing the current currently. It's just doing that inside the wire bundle.
Do you think the length of the wires have a big effect on like the length and the diameter width of the cords effect on the different frequencies it could generate?
Definitely.
Or
So
oh,
the coil isn't limited in its over unity effect by the gauge or the length of wire itself, but changing the gauge and the length of wire will change the frequency that it has to resonate in order to produce that effect, for sure. So everybody's going to have a different range. We can kind of calculate the range based on how long and how thick the gauge is, and we're going to do that at some point and kind of map it out and give you guys an idea of what your resonant range should be with the size of your coils. That'll be fun. That's going to be a project for the future. But yeah, it will affect the resonance and the frequencies it can, I assume, generate as well.
yeah, like a table where it says like let's say 100 feet of this would at a gauge width of that would cause this effect. And just a different testings, nothing like too broken down because that would cost a lot to keep on doing that stuff. But a few good measurements that people could really use and generate these frequencies with. Yeah, I mean, I think that's a very good idea.
For sure, for sure. And a side note here, Daniel does emphasize, I believe it's a 16 gauge wire for anything to do with significant power generation. So if you're like you want to power a large load, that's the gauge wire at least that you would need because the current demand. But I believe it's 16. I'll have to double check, but you just need a little thicker wire gauge. But yeah, the length of the wire and the size of gauge isn't going to affect any of the over unity production or some of the lower end resonant frequency ranges like the magnetic synchronicity effect. It's not going to be affected by the length and size of gauge. That's just going to affect the resonant range that you need to achieve those things. What really matters is the geometry, is getting that geometry as precise as possible. And when you have that geometry, even if it's somewhat precise, apparently, and you have two counter-rotating magnetic fields compressed on top of each other like that, it seems to be pretty easy to achieve this effect as long as it's hooked up correctly and you've bundled the wires and you didn't let them loose around. Like I see a lot of mistakes and I don't know if Jordan from Alchemical Science is aware of this as well, but I did see a couple of his videos and I think he just loosely places them around the coil as well. I don't think he bundles them together and twists them, which what I found is necessary for the over unity effect. So I'm interested in talking to him and seeing his insights on the coil because I know he's tested it extensively, but he hasn't noted any over unity that I've heard him say or note in his Rodin coil guide. So I did send an email out to him, and he is aware that we have achieved it with the Rodin coil. So hopefully he takes a look at my guide and maybe throws his hat in the ring for our contest.
Ben, can you see the diagram here?
1 second. Yes.
Okay, you see the 2 volts with that little coil there? Or let's say 3 volts on your output. Your output is 3 volts, right?
Yeah. Well, right now I can make it lower or higher depending on what the gain's at. Right now it's like 2 point something.
Okay, so your output's 2 volts, right?
2.3.
And that's what the coil's making, right? Right here, that little coil.
Yeah, in the stereo.
See the coil? That's your coil. That's the other coil.
Right, in the stereo amp receiver, right?
That's these 2 ends. The other coil. right?
No, I don't have a second coil hooked up to the load. There might
No,
be
it's open. It's not loaded. It's
Oh,
open.
you're saying the open circuit is a okay. Okay.
And that's your load, right? You hook it up and you
Right.
get your reading there, right?
Right, exactly.
Okay, so over here in this diagram, that second coil is right here. Can you see that?
Yep.
Okay, so that's that coil. Those are the two ends of it.
Okay, so you put that in the diagram there. Okay, cool.
Can you see the
Thank you for
capacitor?
explaining that. Yes, the capacitor. What? And that's what
You could use a polarized capacitor or non-polarized. I don't think it matters, but it'll fill up with some joules that the coil is filling it up with.
So explain
And
what a
you
joule is. I think that's a little fuzzy.
It's
for me.
it's an amp. It's a milliamp.
Okay, so it's just a usable amp or whatever.
You can push those amps. Okay, they're all going to move through the wire at the same speed of light or whatever. They're all going to move at that same speed. But when you have more force behind your source power, you can push more water through the line at the same speed per se. No matter how thick or thin the wire is, it's still going to move at the same speed. That's why the wire burns out when it's not thick enough.
Right, that makes sense. Yeah, because you're trying to push too much through it.
Because you gave the wire too many volts and pushed too much from the source through the wire. The wire is not thick enough to handle the amps, but it's thick enough. It doesn't have to be thick at all to handle the volts. The volts is, will push the amps. That's all it's doing. It's pushing. 1 volt will push 1 amp. 12 volts will push 12 amps.
Right.
But they're all
the amps is
the same. All those amps are not going to move any faster. They're just going to move more of them at a time.
The amps is the volume of water, and the volts is the pressure of the water.
Yeah, you're not going to move anything any faster. You're just going to move more at once.
So how many joules are in an amp?
I don't know. I think 1,000 or kilojoule or something like that. It's metric.
Okay.
It's something metric like that.
What size capacitor is that?
Well, let's say it's it depends how strong of a 2 volt. 2 volts can push, a finite amount of amps. It's not a whole lot of force, right? But it's enough force to push up to a certain amount of amps at once. No, not slower or faster, the same speed, but just more at once. And so you build up in the capacitor over time. You build up more of those amps to match the 2 volt pressure behind it. And let's say the 2 volt pressure, it's technically able to push 2 milliamps. But your coil is producing 2 volts and let's say a 1/16 of a milliamp. Well, what you want to do is you want to build up that 1/16 of a milliamp to a whole 2 milliamps. Like a 2 volt pressure can actually push 2 milliamps. It can't push any more than 2 milliamps because it's only 2 volts.
Right.
The milliamps aren't going to move any faster, but you're going to move 2 milliamps. You can move at a maximum 2 milliamps at 2 volts. And of course, everything under 2 milliamps you can also move with 2 volts. I hope that resonates.
Yes, no, that makes a lot of sense. And this.
So you build up what your maximum potential, the 2 volts can push, whatever milliamps it can push at once in one burst. You build it up in the capacitor. So you get the full, not only do you get the 2 volt potential, but you get whatever maximum amount of amps it can push in that instant as well.
Right, you just get that all as a big pulse of energy, huh?
Right. Right. The 2 volts with its maximum amperage potential that 2 volts can push.
Yes,
right. It depends that amperage potential depends on the resistance in the series circuit, which is don't go crazy here, but it's right here. It's the coil. It's in the series line of the circuit. So that's going to add resistance to whatever the 2 volts has to push through. So that will also limit how much amps you can push through. So then you get into what is the resistance of the coil? Let's say it's 2 ohms, you know? Then and you have 2 volts. And you already know how much current you can push through this coil by using this capacitor, okay? You're not using the coil to push the current through this coil. You're using the capacitor to push current in a pulse through this coil. Does that make sense?
Yeah,
You're using this
it's almost like
coil
a temporary
to
battery.
fill up this capacitor
Fill ups and
then
fills
pulse
up, and
it.
then it pulses as it releases.
Right, you're using the switch right here to drain that capacitor. The negative is being switched.
Oh, and that releases it.
Right. The positive is already connected to the coil.
Okay.
See? It's already connected to the coil, and it's right there. Right? Don't pay attention to this right now. That's probably throwing you off. There's your negative to the same negative of the capacitor, positive of the capacitor.
And the diodes
that's how you
direct
energize
the
this
current.
coil.
And where is would I need a tone generator in this circuit?
The transistor switching will do this right here, or a relay or whatever.
Mm-hmm.
And you want to close this switch in a time interval that is adjusted to where this capacitor is fully charged to 2 volts. And you'll know by reading the voltage on the capacitor. Now, let me just say this. The coil right here is producing 2 volts. But when you put a capacitor in parallel, unload it with a capacitor, the capacitor is going to draw that 2 volts down to a lower voltage, because more than likely the coil is not generating a high amperage. So you'll see a drop, but it's generating some amps, and over time it will fill up this capacitor. That might be 5 seconds, 2 seconds. It depends. Could be less than a second.
So if I see the
don't
input voltage drop below 2 a little bit, that's a good sign. That means it's working.
Right. I would just use a 1 microfarad right here on this
1
capacitor.
microfarad. And also, real quick, you said the transistor, the switch will, that's not gonna, how
use
do I
the Adreno to use the Adreno to trigger a transistor. This is a transistor.
And is that gonna generate the frequency that I need?
Yeah, that will generate your frequency.
And I can program it to the frequency that I want, like the 1,000 hertz that I'm at right now.
Yeah, right. But the point here is you already have a frequency generator going into the primary of your PoE, and the secondary is not connected to a load until you do connect it to a load. And this is what I'm suggesting you connect your secondary load to, create a load for your secondary.
Oh, so just attach it to the system right now.
Right, there's your 2 points on that, those 2 open points on your system right there. Connect it like this to another coil.
Okay.
And switch the capacitor into that coil. Dump the energy of that capacitor into the coil. The capacitor will be...
And that's going to charge the battery?
Yes, because you only have 2 volts here, right? But your capacitor will come out positive here thanks to the diode. It will make sure that when you do switch it, the energy leaves the capacitor and does not go back into it from this coil.
This
when
is
you
awesome.
dump the energy, when you dump the energy from this capacitor into this coil, if you don't have that diode there, it'll be like a tank circuit, and the energy from here will go back into the capacitor, back and forth. But you want it to go into the coil and not back into the capacitor. You want it to go out the coil the other direction into a battery.
So what is this? What is this green up here? That's not a secondary coil, is it?
No, that's nothing. Just get rid of that.
Oh, okay, so that's just a wire.
I was just showing that. So when you pulse this 2 volt potential capacitor from this 2 volt coil that you're getting right now, 2 volts on it, right? So that means, I'm sorry, 3 volts or something.
I mean, it can be whatever I set it to, honestly.
Right, I know. But you said your source was 2 point something, your output was 3 point something. So, well, whatever. say your source is 1 and your output's 2.
Mhm.
And then this 2 right here has potential, which means there's current. There's current as well, because if you have voltage, you have current. So you collect that current into the capacitor until it's maximized into the full 2 volts potential. You use the switch to dump it into this coil.
Wait, so that is a coil.
Yeah.
So what kind of coil am I using for the secondary?
Well, that's this is your secondary from the PoE. You're going to collect the energy.
You're talking
that
okay. Okay, never mind. I'm stupid. So that's the input and the output of the same
right.
coil.
That's the secondary of your PoE. You're going to collect the output from that into a capacitor, using a diode to make sure the energy exits when you close the switch here into the coil. That capacitor energy goes into the coil and dumps it right into the coil. Then the field collapses on this coil, and it will fly back in a reverse polarity.
That's interesting. And
in this way, out this diode. Notice the positive goes out the diode. That's when the pole flips. That's why you have that diode there, to be prepared for that pole flip. Right now it's a negative.
Yeah.
It's a negative because you're switching the negative of your source, which is the secondary of your PoE.
This is a pretty simple diagram. I think I could follow this.
I know. This is the idea I'm going to use to take any low voltage source I pick up anywhere and boost it up to a higher voltage using the flyback method that Bedini pioneered to some degree.
So with this, I would probably
you can rest assured that the 2 volts you give this coil in this polarity, when it flies back into the opposite polarity, it will be somewhere around over 15 volts, I would say.
So which end on that secondary coil?
If it's not high enough voltage, you just add some turns to the coil.
You could add more batteries, right, to harness more energy. Like you could put them in.
You could put as many batteries in series, in parallel, as long as you're not putting them in series.
Where the 2 volts coming out, that's my input for the coil. That's channel A, and then channel B would be the other coil. Which one is the left or right?
Channel B is your output coil to this circuit here.
And then right to the 2 volt.
Right, so this high voltage diode is channeling that high voltage, but I don't think if you're feeding the coil 2 volts,
but channel
you
A
might not need a 400.
But channel A which is right above or right below 15, where you have 15 written. Is that the start or the finish on the left?
Say again, channel A? Well,
it's the start.
We already marked the color. Look. Where is it? Right here. It's black. Sorry, it's black and red, the 2 outputs.
Right, but which one is which?
The 2 open outputs. One is a positive, one's a negative. The red is the positive, the black is the negative.
I know, but in your diagram, which side is which on that coil? Which side is positive and which side is negative? Because you were flipping
red and black.
Okay.
Here's red. Hold on. Let me draw it. Hold on. Here's the red.
Okay.
Hook to that part of the coil. Here's the black. Hook to the other end of the coil. Through the switch, though. Only when the switch closes.
No, that's actually the only missing piece in my mind right now. So I know how to hook
You're
this
asking
up.
the right questions, man. Totally.
And that's why we're here. We're here to learn. And actually, I specifically.
But what you got to understand, though, is that this polarity flips. First, it's a negative, as you see here.
Right, it flips. Right? That's why I was a little confused.
And it becomes a positive.
But yeah, no, I specifically
it goes out here, the positive.
Titled this channel.
And look, the negative.
The way I did
goes right into here. You see it? There's the negative of the battery you want to charge of that coil. The negative cannot, well, the negative, it can go, you know, the negative can go through this diode in that direction. But it's not going to, because when it has the option to do that, this will be open. So that means the other end of this circuit is not connected to the coil. So there's no way for this negative to meet this positive when this switch is open.
The thing that...
So you don't have to worry about that.
Well, the only thing that I am worried about, and maybe it's just me misreading, but right now, channel A and channel B are not connected, but this looks like they might have to be connected.
Yeah, here's how you connect. That would be channel B is your open ends, right? The black and red?
Yeah. No, the yellow and green, but yes, the black and red on your diagram.
Okay. That's channel B right there. I can change it to green if you want. Green and black, was it?
Right, but you see how channel B is leading up to the second coil, and that's channel A?
Is it green and yellow, you said, right?
The current is going, it switches the polarity. So when you're closing that little circuit, that's what's causing it to do the pole flip, because that transistor, that little black triangle facing downwards, that is what determines, you know, how it's going.
Right, but in this diagram, is channel A and channel B connected? Because right now I don't have channel A and channel B connected.
Can you see now? That's there you go. That's yellow is your positive on channel B. Green is your negative on channel B. So when you put a voltmeter to your open-ended coil, and your voltmeter shows positive on that end and negative on the other, you would hook that would be yellow in here, is the positive end. When you read the coil, when it's putting out positive volts, if you flip the voltmeter leads around, you're going to show a positive 3 volts, and then you flip.
Right, but you see where the yellow dot is?
Because
you see
that's how you can determine which side is positive output on the coil.
You see where the yellow dot is? So the current.
Yeah, that's your positive.
Right, but see if you follow the current up past the little diode there, it's traveling into channel A. It's connected. And right now I don't have channel A and channel B connected.
Channel A is not in here. Channel A is not in here. Channel
that's still channel B. Okay, that's all. Okay, then that's my mistake. I misread it.
There is no channel A in here. This is how you take channel B's output and capture it using a flyback.
Right.
event.
No. I was just reading that coil there as channel A on accident. No. Okay. So that makes more sense.
Yeah.
No. This will work then, because
this is channel B.
One of the hesitations I have of connecting using the
This is not channel A. This is a whole other coil, a different coil. But this is your channel B coil right here.
2 sets of things.
Is that an inductive coil?
Your open-ended coil, channel B, is putting out 2 volts, right?
No, not that coil. The other coil.
The other coil is just a regular coil to create yourself a higher voltage.
Oh,
to create
okay. So that's just a regular old coil. Oh, okay. So like one of
right.
The ones that you just
using this method, you can build up your 2 volt with all the milliamps you can put in that capacitor. You can channel the positive out the diode and switch the negative side of that capacitor dump into this coil. Yeah. And when it flies back, it'll be a positive here and a negative here. And when it flies back, the gate will be open.
So what kind of gauge wire are we
You're going to
talking
close the
about
gate
for
to
that?
charge the coil,
So I
right?
just wrap around
Like it is now.
a wire around a metal core?
You could use a core. I don't know if a coreless or core makes a better flyback or not, but I'm pretty sure either or creates a flyback. All you need to do, the only reason to do this is to boost up your voltage. This is like basically a boost plug
Right, yeah, just get a
circuit.
little, okay. So, but I can
So
pretty much
that way
use-
you could connect a 12-volt battery to your, you know, or you can connect a higher battery, or you can power a heavier, not a heavier load, but you can power a higher voltage device.
Can I use the same magnetic enameled wire that I've been using for the coil for that?
Yeah, and just wind some, maybe 25 turns or something around a pencil.
Okay.
And then use that and pulse the capacitor into that coil. Make sure you have your flyback diode hooked up like so to your let's say a higher voltage capacitor or a battery, whatever you want to use to test it out. So, you know, if you have like a 2-volt source here filling up a 2-volt capacitor, or, you know, you're only going to fill that capacitor up 2 volts, but it's going to have more amps behind, more milliamps behind the 2 volts. And you're going to send a nice 2-volt pulse into this coil. And that flyback event will be more than 2 volts. It'll be like probably 20 or more volts. And then in that way, you can now easily conserve the 2 volts by boosting up its voltage and sending it into a battery much easier. Because you can't send 2 volts into a battery unless you have a 1-volt battery. You're not going to be able to charge it with a. You see, you need more than 1 volt over the battery's limit. So if you have a 1-volt battery to charge it, you need 2 volts. If you have a 12-volt battery, you need 14 volts to charge it. So you only have 2 volts here. That's not going to charge a 12-volt battery. But you can use the 2 volts to create an inductive spike, to create a higher voltage.
And remember, the 2 volts gets changed to at least double. So that's
more than that, actually. It's like at least 10x, I think.
But
Okay, say that again. Like a 2-volt battery will not produce 12, but what are the ratios again?
Like an inductive spike on a 2-volt pulse will come out around, 25 volts or maybe 50 volts. I know if you give a coil 12 volts, the inductive spike on that is, and it also matters how many turns you have on the coil also. The more turns you have, the higher the spike. Because I've done that with a coil, I put like 5,000 turns on it with I guess a 28 gauge wire or something like that. It's a older coil I made years ago, and I was, never burned out the transistor because the resistance on that coil was, I think it was over 50 ohms or something. And if if you're pushing 12 volts through a 50 ohm coil, you're not going to be able to push a whole lot of amps, and thereby you're never going to burn your transistor. So that's why that transistor still runs today. But I was measuring the spike on that in around about 900 volts. And I had coils that had less turns than 5,000 turns. And, you're talking, I mean, it was 1,500 turns. I had other coils with like, 300 turns or whatever, and that would produce like 400 volt spikes. You see what I'm saying?
Yes.
So like, you don't necessarily have to wind a bunch of turns to get over 12 volts here. You probably put like, who knows, man, maybe 25 turns will do it. It'll get you up to like, I'd say a 50-volt spike on a 12-volt battery is enough to get the energy into that 12-volt battery nice and efficiently without any loss, because you got a nice high voltage pressure behind that jolt of energy, and it's cutting across the lines without any, thing getting in its way.
So you
right
have
to
to
the battery.
start with the double amount of whatever battery you want the load to be dumped into. Like the initial start would have to be doubled whatever that battery voltage is.
Yeah, I mean, not double, but a 12-volt, 12.5-volt battery, a good charge voltage for that is like 13 and a half, 13 0.8, around there.
Okay, okay, I'm not understanding. What
So
is
it's like a
the
1.8 volts more than 12 volts is what you're going to need to charge that battery back up to 12.5 volts.
okay?
You give it 13.8 volts, but it's, it will charge up and read 13.8 volts. As soon as you remove the 13.8 volts, it drops down to 12 and 12.8 or something like that. A healthy battery
Oh,
does it like that.
oh, that's cool.
So the battery is rated for 12 volts and 12 to 13. It depends on you can make a battery with a higher voltage rating by giving it more cells, more plates, more stacks. You stack the plates together more times and increase your voltage. But those batteries have more issues because there's more plates and they're easier, more problems, more easier to have problems. It's just, you could store all the energy you want into a lower voltage battery if it has the capacity. It's just going to be it's going to take up more space. It's going to be the plates are going to be bigger. Like a 2-volt battery is probably just 2 plates, anode and cathode, isolated with a electrolyte or something like that. And like a 12 volt is probably like 10 plates or something like that.
So just a quick update. I was testing the different different waveforms, specifically the sine against the square, and it does seem, so if you're doing, this is just if you're doing experiments with your own Rodin coil, it seems like the square wave does produce more over unity. For the sine wave right here at 1800 hertz, we're getting 1.79 volts on the input and 3.3 volts on the output. But if we change that sine wave to a square wave, that goes from, it increases a little bit on the input, 2.2 volts on the input, but the output's now 4.2. So the over unity effect kind of increased a little bit. And that's with a square wave.
Yeah, well, with a square wave, you have a sudden drop off of your source power to the coil, and that creates a much more effective spike, a higher voltage.
Right, that makes
flyback.
sense. But it also makes the signal really bouncy and unstable, doesn't it? You need something to smooth it out at the load end, I believe.
Say that again?
I said, I believe it makes the signal real bouncy and unstable, so you have to kind of smooth it out when you use it, right?
The flyback? Yeah, well, you could
The
smooth
signal.
out the flyback. You could use a regular battery to smooth out the flyback. Or you can use a high voltage capacitor that's rated for let's say your flyback voltage is like 300 volts. You'd need like a 300 volt capacitor array to smooth out that flyback.
My name is Ben.
But
yes, my name is Benefactor. That's my pseudonym. I actually didn't make it impossible for people to find out who I actually am, but I wanted to make it hard just because I was dealing with some sensitive topics when I first started this channel. And it also gives people a mystery, like who is this guy? But yeah, that's the basis behind that. I just messaged the Nunez on Facebook. It gave me an auto reply. Hopefully they're still there. You can get back to me. Last time we talked before they went dark, we were about to collab. Yeah, that's I don't know. Did you message them on their First Stop Energies Facebook, or did you have their personal Facebook? Because I don't have access to their personal, but I tried reaching out to them many different occasions on email, on Facebook, and I think I even tried calling them on their office number, and I wasn't able to reach them at all. But if you can reach Daniel or Eric and Nunez, that would be awesome to get them on your show for Friday or whatever. I would really, really love that. As you can see, I'm following in their footsteps, and they're the best source for some of the problems I'm having, and you know, the brick wall that I've come across with the Nunez method, open circuit. So yeah, if anybody can get a hold of Daniel or Erica Nunez, just so, you know, maybe we can have them on and you know, talk to them and see if they're okay. You know, I kind of am hesitant to do an information poll on them, but yeah, it would be nice to know that they're okay.
I don't know them, but I hope they're okay.
Yeah, what I honestly, what I assume is that, because I heard rumors that they got sued, which doesn't surprise me. Daniel said there was like at least 10 companies copying their design while they were trying to do their patent, or maybe right before they or rolled out their patent or whatever. But yeah, they were relentlessly suppressed, and I have a feeling that maybe they were ordered by a judge, got a gag order, and say, you know, you got to take these down off of YouTube, or you know, you can't talk about this anymore. I honestly don't know, because they weren't actually, I don't think they weren't actually infringing on anything by selling the coil kits, but the fact that they actually tried to patent it might have pissed somebody off. Which is why I emphasize that anybody trying to replicate this experiment with these coils, it is not for monetization. It is simply for scientific exploration and educational purposes only. And as Crypto says, real science gets a lot of love on this this channel. And I hope that anybody who tries to build a Rodin coil doesn't go that path, because it is nothing good. This is science, and it should be freely taught to everybody, but there are still entities at play that would not like somebody trying to patent one of these again.
It's not as much as for the patents, but more rather for not creating this device. So they give a hard time to people that, you know, want to create a spaceship, you know, want to like have the independent, you know, idea, aside from, you know, regardless of who invented it, or, you know, or if it's real or not. But the second that, you know, you know, like in anything that it's hinted that, oh, we could possibly break away from this, you know, manufactured grid, oh, you know, this is where the weird stuff happens.
And that's honest. That plays into my theory is, as soon as you patent a device like this, you're saying to the whole world that the science is real, and it's all hands on deck to competition to who can build the best one, or who can find the most efficient design for this kind of new science. And they don't want to admit that the science is real. They'd rather suppress it.
Okay, I mean, this is my understanding. The people that make the policies, rules, and laws, they probably failed chemistry and physics.
No, you're right. Most people, especially the politicians, probably aren't aware of this. But there are certain people in certain heights of industry that do. And it's very, very few select people, probably only a handful in the entire world. But they're out there, and they know exactly what this technology is capable of. But they'd rather destroy the planet, you know, and each other, rather than, you know, letting us explore actual science. But you know, things are changing. The thunderstorm generator's out. People are talking about it. They can't suppress it anymore. So what the industries have to do is adapt, and that's what I suggest they do. Is, you know, find a new business model. You have a lot of money, you have a lot of resources, you have the ability to adapt, put your money and resources to good use and make more money some other way, you know, be creative. I challenge you to adapt, because that's what life is about, adaptation. And it doesn't mean that, It doesn't mean that oil or coal or fuel is going to be phased out immediately, but there probably will be some kind of transition period for, 50, 60 years where we're still using coal, oil, and fuel. So you have a lot of time to, try to change your business model.
They should reserve it to like plastic manufacturing and stuff like that, because that is kind of hard too.
There's still going to be a lot of things that are going to be needed to be done in the world regarding industry and our economy, and they still have roles to play. If they want to fill them, then they'll have to adapt. But in in the long run, it's something that I think the people themselves, the majority, are going to have to kind of emphasize, because what I think is going to happen is, since the cat's out of the bag, they're just going to ignore us as much as possible, or try to, ridicule us, keep us off the mainstream news. You're not going to see any news articles coming out on Fox or CNN about the thunderstorm generator anytime soon, even though it's running right now in North Carolina with a bunch of people who can clearly see it and brought their own, testing equipment, and they have the inventor there explaining the science behind it, who's been working on it for 50 years. So things are changing. But I think that the people will have to start building these devices themselves in order to get any kind of real attention.
That's smart. Yeah. That way they gain the credibility, like the credibility
behind it.
When they have a prototype.
Right.
Absolutely.
Right. And I think I'm optimistic. I think things will change for the better, and things won't get completely better with, these free energy devices, but they will help alleviate specifically people in third world countries who have limited access.
That's smart. Yeah. That way they gain the credibility, like the credibility
behind it.
When they have a prototype.
Oh, believe it or not, some of them third world countries.
I'm
very
optimistic.
efficient
I think
systems.
Things will change for the better. Yeah, I've been seeing some free energy devices come out on YouTube. Oh, I'm getting echo. But they will help alleviate specifically people in third world countries who have limited.
There you go. Echo. A solar panel is a free energy system, so.
Yeah. And I've seen other people in other countries on YouTube and Facebook showing off their, free energy devices or energy saving devices that, are unconventional, but I haven't looked into very many of them, but I mean, they're popping up. People are posting about them, and I have been posting about them. It's just they're being ignored. The algorithm's not picking them up on Facebook and on YouTube. I think it's just flooded with the same kind of stuff regarding people who are con artists who are getting mixed in with the free energy device enthusiasts. And that unfortunately lowers our credibility when you have somebody like, I'm sorry to say it, but I'm hearing that Ashton Forbes is heading down that road. He's claiming that he knows somebody who has an over Unity device. He doesn't want to release any information about it unless you pay him. So I'm immediately skeptical of anybody who has some kind of new groundbreaking science and they don't want to immediately open source it.
Well, yeah, they're trying to profit off something.
Yeah, but how would you believe their device works if they don't tell people, they don't show people that it works?
Exactly. Replication is what's needed, and you can't replicate it if you don't know how it works.
Yeah.
But regarding patents, it's nice and it's good. I don't have a problem with people patenting their designs to make money. But when it regards new groundbreaking science that everybody deserves to know about, that is a different story, Like
well, why don't they sync it? Like they release how it's, the technology while they patent it on the same day. That way, they enjoy best of both worlds.
That's an option too, like have a time delay system where, if your patent goes through, it'll automatically open source some of the science. I know some of the my multimeter ring. So some of the inventors like Stan Meyer, who tried to patent their devices, left out specific details because he didn't want, patent trolls and other people infringing on, his one chance to, make a lot of money. So
all it takes is to change like one part of like a wire, like the density of the copper or whatever the conductive material. All it takes just because it's a series, like any element is a series of densities, and then till like it becomes to the second element. So if that density though, that you could change that a bit, and then and put whatever you want on there, but that at the end of the day there's like that one little bit of a percent you change it for like security purposes, for somebody not stealing your idea,
Right. And I know Stan Meyer, I think he left out two key details from his system, if I'm not mistaken. He left out the specific frequency that he was using for his ionization chamber, and he left out the fact that he was resonating the tubes in the system. And I've seen people online, trying to replicate his very efficient electrolysis, which is very efficient when you resonate it, but they haven't gotten the fact that they need to ionize the gas first to precondition it for cavitation.
The person could like say, contact me for rights, if that person wants to give that last bit of the secret sauce, on
I thought of a good idea earlier when you guys were talking about the POG system and the air currents in two directions.
Yes.
Right.
Well,
okay. Check this one out. You know what a wind generator is, right? It picks up the wind, right? It spins the wheel and generates power. What if you had two pipes designed to pick up the wind and channel the wind the same way the POG generator channels the two airflows?
That's interesting you said that, because
and this wind generator pipe design was made out of a conductive material, and the two pipes were insulated or isolated, and you had your natural wind flowing through two pipes that are isolated.
Listen, this is really cool that you're saying
but the wind's flowing in two directions. That's a very complicated thing to do.
This is really cool that you're saying this right now, because this ties into the ancient technology connection, and I'll tell you exactly how. There are chambers on the Great Pyramid wall that are angled at specific angles, and they allow air to enter at specific angles. And we know that plasmoids have to be ionized to form more abundantly, and they have to be and there's a natural ionization process in the air. And we already know that plasmoids cluster up more efficiently when they're introduced to each other at a specific angle. So there's an ongoing theory now that the Great Pyramids were channeling plasmoids through natural air streams, and they were colliding and producing massive amounts of energy just naturally with the geometry.
Not only the granite slabs are quartz. They harness piezoelectric electricity in them.
Right. So what you can do with those plasmoids is you can feed them into that chamber and use the frequencies to disassociate the molecules.
They harness piezoelectric electricity in them.
Right. So what you can do with those plasmoids is
I'm
going to echo again.
That's crazy. So that's what those holes are for in the
It
pyramid.
it might be. That's my theory. I put that into the Divine Science
Makes
documentary.
sense. The wind's hitting the side of the pyramid at that angle. It's flowing right up that angle,
Right.
right into the
And get
hole.
this. The angle for the concave on the pyramid wall is 51.84 degrees. Guess what the angle of introduction is for the plasmoids in the thunderstorm generator? To successfully discharge, they need to be 51.84 degrees. And you know what that adds up to in vortex math? Those numbers add up to the base number 9, which is said to be radiant energy, 0-point energy. It radiates out of 0, the vortex, as 9. It's
51
really
point what?
51.84. So when you add those numbers up and you reduce them down to their base digit, it's 9.
Yeah, 5 plus 1 is 6. 6 plus 8 is 14. Plus 4 is 18. 1 plus 8 is 9.
Right?
I
Vortex
love
math.
it. I love it.
Yeah, and it's so
So
simple
easy.
to do
Once you
vortex
do it a
math
few
when it's-
times, you get it.
Right. I mean, vortex math can get very complicated, but the basics of vortex math is very simple. It's all about adding and
Right.
subtracting and reducing that number down to that base number. That's it. I mean, I think there's tripling involved too. I haven't really gotten into the advanced stuff yet, to be honest. I'm not a mathematician. Yeah, this is all very
Yeah,
fascinating.
well, I don't know. The Egyptians were masters at more than just, I'm not sure it was the pharaohs, but the Egyptians were masters at more than just chemistry. They were masters at math too. I mean, they're the ones that said that. I mean, I heard this anyway, that they dictated the metric system by using a drop of water. They say that the size of a drop of water is 1 centimeter.
That's interesting.
And if you look at a drop of water, it is 1 centimeter.
Right. Huh.
If you know what a centimeter looks like, it's always the same dimensions. 1 drop of water.
Yeah, no, I
That
never
was their
thought about it
basis
that
of math.
way. That's a very brilliant way of getting a base
yeah,
unit.
100 drops of water is 1 meter.
Yeah, that's a brilliant way of getting a base unit to base your number system off of. No, that's brilliant.
I saw a video online about this somewhere.
Yeah,
So-
exactly.
They-
How much is, like what's the dimensions of a drop of water on a flat surface? Yeah, absolutely. Yeah, it makes sense.
It shows you their mentality with math. And if you look at the scarab beetle, it kind of is the similar mentality there with chemistry.
I
how
hate
they
this.
how they translate the knowledge.
I hate this mentality that people have, especially in mainstream archaeology. Like our ancestors were stupid as like they weren't stupid. They had the
It's-
same mental acuity we have. Anatomically they were
It's a
exactly
mentality that spans the generations of time and civilizations that no matter what civilization you are, what epoch, you're gonna have to come across certain forms of science and math or whatever you want to call it, engineering, something like that's going to come in your way. You're going to have to run into these same things, these same principles that the earth presents us, no matter where we go or what we do. It's going to be showing up the same principles in one way or another,
As above,
It'll
so
look
below.
like this here and look like that there, but it's the same principle.
I think we have to, modernize our cultural and, religious beliefs to tailor it to what do we see evidence in the science that could explain what they were talking about. Because remember, till modern days, we know what a particle is and what it could do, or what an atom is, or electron, or proton, or neutrino, or the fundamentals.
I absolutely
But then
agree.
when they saw, things that they couldn't explain, they drew whatever was to the ability of them explaining it
Mhm.
or magnifying it, either way, macro or micro, and writing or drawing these things for us. And so, or telling stories about it, like, I love the one about the Moses split the sea. It's like, okay, it's a cool story, but now let's think scientifically. What could have was happening on a solar level? Like, what could cause that? If
Right.
we talk about, what could cause that scientifically? What kind of
This is interesting too, because this goes back to the molten sea arc atomic reconstruction technology, and what Malcolm found. He traveled all around the world and in all these different libraries, even the Vatican Library, and he studied the dimensions of the Ark of the Covenant and the molten sea arc. And he came to the conclusion that based on the sacred geometric principles of those two ancient items, that they were utilizing plasmoid technology. They were the last known plasmoid generators and capacitor. So the Ark of the Covenant, he claims, was a capacitor to hold the plasmoids, and the molten sea arc was the generator that cavitated the plasmoids. And if you look at, I guess, the geometric configuration of both of those historically, they match up with his theories on how he created the plasmoid unification model and the thunderstorm generator, which is really wild to think about.
I mean, it makes sense because in one of the stories it says like they had to insert two poles from two rings that were like four rings attached to the Ark of the Covenant in order for the whoever's lifting it up not to touch the actual the actual gold, or
right, like it was conducting something, right?
Yes. So yeah.
Yeah, it's fascinating, and there's a WikiHow page on Malcolm Mendel, and I think I have it linked to in my website, beneficencetv.com, where he talks about some of that and more in detail and how he came up with those theories, and it's really fascinating.
Absolutely. I love this, like, trying to understand old stuff into a modern day application, or in a lot of cases they were way more advanced than us.
Hey, Daniel,
they knew
how you doing?
They used natural things to create exuberant amount of energy from thin air.
Right.
And right now our we have to use so much more things to replicate, where we don't have the ability of using the same natural products that they use. They use like stones.
Right.
They use,
as Randall Carlson says, if we're looking for ancient technology in the form of a reflection of our own technology, we could overlook it completely because they could be doing things drastically different. Utilizing the geometry instead of the current. Circuitry like we do now. We have circuitry, and we try to see how many transistors we can fit on a processor instead of what Marco Rodin suggests with Vortex Math. It's about cycling. It's not about how many components you can fit on that circuit, but how many times you can go around on that circuit.
I mean, imagine this. Do you see how you have the image of the pyramid? Think they harnessed natural wind flow to create a hum, a vibration.
That's what I'm thinking.
And like everything, vibrated. They used the natural wind, that motion of the wind where it's gonna, that creates an effect. So the whole pyramid is gonna vibrate. Like if you were to do the skim.
Yeah, and it's made of quartz crystal, which is a piezoelectric.
Yes.
Electric. Right and there, so, piezoelectric.
But there's so many of them that it gets amplified. So when eventually the signal reaches the top, it might have been extremely visible, to the naked eye.
And guess what else was made out of quartz crystal? The obelisks, and they're shaped just like large antennas, and a lot of them were coated with electrum, which is, I don't know if you know anything about electrum, but apparently it's really good at
first time I've heard of
plasma.
Is that the green stuff?
It's a mixture of gold and silver, but it's really good at picking up plasma.
Never heard of it.
I think it's like I think it's green.
But a lot of
I'm
them
not
were coated in electrum, the tips of the obelisks, and they're way up in the sky. Like, it all makes sense, you know. Like, what if there was a pre-dynastic Egyptian culture that was way more advanced than anything we're capable of, you know, doing even today, and it was just lost in time, and the modern Egyptian culture kind of tried to replicate that, and they did a good job with the math, but they couldn't get the pyramids right. You know, you kind of have two different kinds of pyramids in Egypt. You have the perfectly symmetrical and massive megaliths, and then you have kind of like the mud brick pyramids that are, you know, all over and deteriorating. So it makes you wonder, like, you know, like, why is what's his name, Graham Hancock, not allowed in Egypt anymore? Because he's talking about something that they don't want him to talk about.
My God, I was watching something yesterday, and I don't know what the show was called, but they're like the extreme misinformation, disinformation. It's like, dude, no, that does not mean that. And they're just like blabbing, you know, nonsense. And this is on.
Oh, it's
I think it was the
infuriating. Like, I have people on Facebook that, you know, like I you know, they know I'm working on a free energy device. You know, they know I'm working to achieve over unity, and they don't think it's possible. And even with all the evidence that I presented them, they don't want to even look at it. They just, you know, dismiss it. So it's really sad. Like, and there are some people who are open to it, but they won't acknowledge it unless they can see it with their own eyes, see something that works. So I mean, like I said, I can show somebody numbers on my multimeter all day, like my friend who is very stubborn and very stuck in his mainstream ways of thinking scientifically. I could show him numbers on the multimeter all day, and he's just going to make up some kind of excuse in his head to rectify the paradox that he's trying to, you know, go over. You know, like, it's almost like a form of cognitive dissonance.
Because it's very hard to go against this, you know, the stream of information that's, you know, accepted by the public.
Right.
And it's what, like, it's challenging like other physicists, other, you know, inventors, other, like, on things that they've already gotten accreditation for, you know.
Right.
So
exactly.
Very difficult. You know, it's like, you know, the old generation never listens to the younger generation because they assume that, you know, the younger generation doesn't know as much as them. But they don't understand that the balance is that technology is evolving. So yes, the younger generation will know more than the older generation.
Mm-hmm.
You know,
and a lot of times change makes most people uncomfortable, and when you have such baked in preconceived notions about how the universe exists and how it is, you know, and you are confronted with something that fundamentally goes against that belief, I think people are just scared. You know, like, maybe they're not aware of it, but they're afraid to confront the consequences, you know?
Yeah.
You want to hear a mind twister here?
Yeah, sure.
Yeah.
You got a piece of quartz, right?
Mm-hmm.
And you have it compressed with two plates of stainless steel on both sides. And you tap, you get your voltage on the two plates of steel, right? You put the quartz under 10 pounds of pressure and you get 10 volts, right? So how is that not free? Do you have to, you just leave the vise on the two plates pressure with the pressure?
What means of energy are you using to put the pressure? You know,
a vise, clamps, whatever, tape, a book, gravity, mass.
You constantly.
I'm sorry, matter. That weight, 100 pounds on both, just on the table on top of the.
Will the quartz crystal continually push that out, the voltage?
I'm thinking it will if you can find a way to slightly vibrate the weight that's on it.
Oh, so
so
while
that
it's
it
tight in the grip of
has
the
a slight
vice.
release. You know what I'm saying?
Yeah.
Because I know
that
when you
makes
let
sense.
go and you push it back down again, they have these little hand quartz generators that you push the button, it makes light.
I mean, you could
Keep
put it on
pushing
a magnetic plate and put a Rodin coil underneath it.
Well, I mean, you know those lights that you push, they make energy, or they're the ones where you wind it, it makes energy. But they have ones that you just push a piezoelectric plate. You keep squeezing it and it charges up. But you have to keep squeezing it on and off. You know, letting go of the pressure and reapplying the pressure.
I'd like to definitely work with some quartz crystals at some point. That seems like it would be fun. I know John Hutchinson had a crystal battery. He kept the secrets of it disclosed to himself, but I think there are some theories on how it works. Maybe we can look into that at some
Well,
point.
what I know is that, you know, if you pressurize the quartz and you hold the pressure down, you get your 10 volts, and at that instant, whatever the amperage that you created in that event gets transmitted, and then it's gone, but you still have the 10 volts of pressure there until you let go. So, you know, by holding the pressure down with an electromagnetic field and then releasing that pressure really quick and bringing it back down really quick onto a piezoelectric material, it's a way of creating solid state power, in my opinion.
That would
Because,
definitely.
you know, you do it with your hand at a certain rate, and you know, you can only go so fast. But
Right. Well, depending on the mechanism in which you
like a
squeeze it, I guess,
solenoid.
yeah, that might work.
use a solenoid to push down and let go really fast on the quartz, and it'll put out the same voltage with the same pressure because you're pushing the same pressure.
Oh, Daniel said, I'm sorry, I didn't mean to interrupt you. Daniel said, I will share my standalone generator builds for my anti-gravity power booth. If anyone is interested, I will record that and comment edit later. Ooh, that sounds really interesting. We will definitely have to check that out. I would love to see that. You talk about later today? Later tonight?
The link's in the channel. You can join anytime.
I might take a break here in a minute, if that's cool with everybody.
Yeah, me
Yeah,
too.
so that's the quartz piezoelectric thing, you know, and the pyramids are full of quartz, and pressure is not constant, it's varying, so you would have all kinds of, you know, things going on there with the wind and the barometric changes and the barometric pressure, and I think they figured it all out, you know, so they even knew the moon and all that, the pressure changes.
Oh, they
took advantage of all
yeah,
that.
they definitely figured probably that and more. I mean, they knew more than we know now. That's for sure. And they were more open to you know, more spiritual roots for answers, you know, and open to more of the metaphysical. Like we're kind of closed off to the metaphysical here. Like anything, and you mentioned the aether to somebody, and they either A, don't know what you're talking about, or B, think you're crazy. Or, you know, there's that C option, and they think you're talking about something from Marvel Comics, but
they aligned their structures where, like, for example, like the solstice, like, you know, summer and winter, and the lunar cycle as well. And so their alignment was always, you know, where they could harness a continuous light source, you know, and densities of the, because if the sun is closer, it's gonna heat up the solstice, like, you know, summer and winter, and the lunar cycle as well. And so their alignment was always, you know.
Oh, sorry.
Why is there a relay? It's weird.
Never mind.
But yes, there's a intimate relationship between the celestial bodies that Malcolm goes into in his plasma unification model. Everything's connected from the microscopic to the macroscopic. These systems, when they gather into clusters of galaxies, they exhibit the spiral pattern. Just as we zoom in the microscopic, we see these spiral patterns, DNA and other things. So as above, so below. If we don't have a unifying way of understanding things, then we're going to drastically misunderstand them.
We have to unify, the smallest unit of what does that equal to, and then we grow the equation to our, it's probably alter a lot of, our metrics. We have to agree upon what is time, what is, the oscillation of this, element, what is, we have to unify that. Can't we, first, like each government has their own, standard.
What vortex math has taught me more than anything is that our way of calculating, it's gotten us so far. But if you look at how we do linear math in a three-dimensional world, it doesn't really, it only gets us like 20%. If we use vortex math, which is a three-dimensional mathematical system, then we get to the other 100%. And I don't think people, most people in the academic world realize that they're missing, especially in computer science, they're missing a critical component, which is the 369 pattern.
It's amazing how when you take like the number 9 or the number 3 or the number 6 or the number 18 or the number 27 or the number 36 or the number 108 or the number 90 or the number 45 or the number 180 or the number 360.
And you want to know something crazier, though? You take that one step further. So if you look at the vortex math diagram, 3 and 6 are on the opposite side of 9. And in vortex math, it is said that 9 gives the other numbers, 3 and 6, their polarity because it's representing a magnetic flux field. And get this. So when you add 3 plus 3, what does it equal? 6. 6 plus 6, 12, reduces back to 3. It oscillates back and forth. It doesn't matter how many times you double those numbers, they will always oscillate back and forth with the energy that's emanating from the 9th vector. It's really mind-bending stuff.
Their square root. They go back to their original square root.
If you have a 9,
it's not just about square rooting. It's not just about patterns. What vortex math tells us is that numbers are actually real, and they represent physical vectors in space-time, ones in which the fractals of creation are based on. So if you can imagine,
maybe the numbers 3 and 6, that those whole thing with 369, maybe that is the formula for time, and maybe the Egyptians knew the numbers as well like that, but also in another way, not just in the formulation for time as vortex math might be. But I think the Egyptians also knew the numbers in another aspect as well as
for sure,
their relationship to chemistry. What I'm saying is their relationship to chemistry. The numbers 1 through 10. I believe each one of these numbers represents a certain chemistry or chemical or whatever, chemistry formula or process. I'm not a profound chemist by any means.
Well, that's
but
interesting.
I have a good
I know the Egyptians were really good at chemistry, and I don't know specifically about their math techniques.
Yeah, and I think that the numbers are the key to their chemistry techniques. Like the number 5, let's say it represents some certain chemistry process that's probably well known today,
Right. No, that makes sense.
Something like that, and maybe there's like 10 or 9, sorry, because there's only 9. No, there's 10 digits. There's 1 through 9 and there's a 0. What is the 0? Maybe the 0 is not the 9 is the vortex. math. 3 is the vortex. The 6, and 3. That's probably time and as well as energy. But what is 0? 0
Five,
the
5 is your 4D.
is 0 the
1 to 2, it would be 1 is 1 dimension, 2 like from a point from A to B would be 1.
0.
B
0 is
T
A in this chart.
would be 2. C to D connected with A, B, and C. Then the center would be E, and that would be 4D, because when you reach the top, that would be 3D. But then the 5 unit would be the 4D.
Crypto Alchemist said 0 is neutral. I'm not an
It's
alchemist,
A at the
so I don't
top.
know what that means, but I'm sure that has some kind of relevance.
1, 2, 3, 4, 5, 6, 7, 8, 9. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A. A represents 0.
Oh.
5 is
My headphones just
vertical
died,
to
so
0.
I'm gonna take a quick break, let them charge for a minute, and I'll switch to the intermission screen. We'll probably take maybe like a 10-15 minute intermission. Does that sound good?
Yes.
Okay.
Yes.
Yeah. All right. Everybody, we're going to go on a 10 to 15 minute intermission. We will be back with more mind-blowing science.
Gonna tear off a slice of turkey. Lulu, looks like A is.
Throughout modern history, there have been visionaries who dared to dream beyond the boundaries of conventional science. Inventors who sought to unlock the mysteries of alternative propulsion, anti-gravitics, and the enigma of over-unity energy. Yet, their stories remain shrouded in shadow. Many of these pioneers, their voices silenced, their visions extinguished. Some vanished into obscurity, while others paid the ultimate price. Suppression, it seems, has been a constant companion to innovation. But recently, there's been a glimmer of hope. A new generation of self-taught, open-minded, and independent scientists has emerged. A collective effort to combat the forces that seek to keep humanity in the dark. People like Rodin, whose rediscovery of vortex-based mathematics is nothing short of mind-bending. They pushed the boundaries of mathematical understanding, opening doors to a new realm of possibilities by describing numbers as physical stationary interstitiary vectors in space-time whose values don't change. Unlike traditional mathematics, where numbers change while functions remain constant, this paradigm shift recognizes that in reality, functions themselves can represent the changing variables, opening doors to a new understanding of mathematical relationships. And then there's Malcolm Bendall, a man with a vision that defies convention. He introduced the plasmoid unified model, a concept that calculates the resonant frequencies of everything from the elements to colors, shapes, and even polarized cardinal directions. Theory. He applied his unified field theory to a revolutionary concept, converting mass into clean energy. His ingenious design mimics nature's use of plasma, producing colossal amounts of pristine energy. Bendall's vision goes beyond energy. It's about reshaping our understanding of the world and harnessing the very forces of nature to propel us into a new era. As Tesla was once accredited as saying, throughout space there is energy. Is this energy static or kinetic? If static, our hopes are in vain. If kinetic, and this we know it is for certain, then it's a mere question of time when men will succeed in attaching their machinery to the very wheelwork of nature. In the shadows of suppressed technology, these visionaries are opening doors to a brighter, more sustainable future. The plasmoid engine, a symbol of hope, innovation, and the relentless pursuit of the unknown. Join us as we delve deeper into the mysteries of plasmoids and the brave souls who dare to challenge the status quo. Here on Divine Science. Stay tuned for our brand new show. For more videos on consciousness, zero-point energy, and other forms of forbidden knowledge, like and subscribe to my YouTube and TikTok channels. What are you waiting for? Take the red pill and arm yourself with forbidden knowledge. Subscribe today.
Hello? Is anybody there? Oh, hold on. Hello?
Ooh.
Oh, there we go.
We're here.
How you doing?
How's it going?
Sorry
Get
about
some
that.
food in you there?
I had to drop off the girlfriend to work.
Oh, okay.
But yeah, I'm back now. So if anybody is joining us, we were talking about some ideas on how to continue with phase 2 testing of this Rodin coil system. And we were also, what were we talking about before I left?
Stan Myers, and then it was the Pogue.
Either way.
Talking about them coils.
Yeah, we were talking about a lot of different stuff. But actually, I'd like to, if you want, get updated if you guys are working on any projects, if you'd like to update me on your stuff.
I do energy channeling, you know, and this is more of a telepathic thing.
Oh, okay.
And sometimes it hit different things appearing in the sky, and I have like a bunch of videos.
Oh, that's neat.
Oh,
I'd like
I
to see
remember
some of
that.
those.
Yeah, so I got interested in this whole field because of different anomalies I started seeing, and I couldn't explain it.
Right.
And you know, and somehow
I do energy
joined
channeling,
APEC,
you know.
Oh, we got an echo.
things more of a telepathic, like things started clearing up for me. Like it was like, oh, okay, now I understand. You know, like okay, and you know, the more I learn, the more I refine, you know, the science of exactly what I have recorded.
I feel like,
You know?
Yeah, I feel like from my personal experience, stuff like that is like somebody tapping into the Akashic record, and
It's amazing.
Yeah,
amazing.
Some of my epiphanies.
That's an interesting way of looking at it.
Yeah, that some of my epiphanies seem to come out of nowhere. You know, not all of them, but sometimes I'll have an idea. I'm like, where did that come from? You know, and it's out of this. You know, I don't have the basis of knowledge to form that idea, but it just pops into my head.
Absolutely.
Do you think UAPs is also like that kind of same kind of thing going on?
Man, it works like with true intent, with true purpose. Like when you ask, you know, not with words, but like with just the energy of your thought, it responds.
That's interesting because Dr. Stephen Greer reports the same thing with his experiences.
I don't know about Dr. Stephen Greer, but I know about
I don't know, man.
You know, I don't.
I had one experience that might correlate to what you're saying.
Listen, for me, I don't know, you know, who Mr. Greer is or his, you know, what he said, but I'm telling you my experience.
Yeah, no, I believe that for sure because I've heard similar things from different people. So,
I have videos. I've got videos. I have a video, like a live video. It was an Apex conference live, and I was a participant in it. And I was sitting in my backyard. I had the speaker on because I was working, you know, different things in the backyard. So, you know, it was on the big speaker. And I had another phone that, you know, I kept like my older phone because it, you know, so I could still record videos. I could still listen to YouTube. I could still use my email like separately from the device that I, you know, communicate with, so it doesn't get interrupted.
Yeah.
Well, I'm sitting there listening, you know, and participating and working, you know, all of this. And then I look up in the sky and I see something like it's not natural. You know, its motion is erratic. It's, you know, and it's it's way higher than, you know, like what a drone could be. You know, as I'm filming it, like keeps on just like, you know, disappearing from one end to another and like really, really fast at pace. And I'm recording this, and then the plane happens to pass by. It's funny because I live next, you know, close to an airport.
Right.
And you could see a bird flying in the sky, and you could still see that thing, and it's moving, and then it just, you know, and you could hear the APEC conference in the background of the video. So at that same moment, I uploaded one video, like the video that I took, to I emailed it from one phone to another, and I uploaded it to APEC live, so they could see. Like, I'm not kidding, you know, this is it gets attracted by scientific mind. It likes to, I guess, somehow give synergy to the topic. So people, you know, become more in tune. They like, you know, become like a group coherence state. And, you know, like information and ideas gets bounced, like it's an oscillation to create whatever, you know, we're seeking, you know?
Yeah, it's almost like if you look at one of my videos on my theories on parallel universes, I think.
Can you hear me?
Yeah, can you hear me?
Yes, sir.
Hello.
Hello.
We can hear you.
We hear you. Go ahead.
She might have a problem with her audio.
Probably.
But what I was saying is if you look at superfluids, and this is from one of my videos, Parallel Universes Part 2, there's something called coherence when you know a fluid like liquid helium achieves the superfluid state. There's a threshold effect. So there's a certain threshold, and I think it's like for certain systems it's like only 20%, and you have 20% of that
Military
system.
personnel capturing the footage said that the UFO exhibited characteristics that cannot be explained by any known aircraft or natural phenomenon. Also, they added that this UFO was definitely smaller than an aircraft. So maybe it was an alien probe sent to survey the airport area. The CBP aircraft continued following the sphere for more than 10 minutes.
This thing, they're calling it the jet.
Okay, I'll put your footage up so everybody who's watching should be able to see what we're watching too.
Is that David Blaine? Or what's his name?
I hate David Blaine. Or not David Blaine, Chris Angel?
That's not Chris Angel, that's David Blaine.
Oh, okay. Chris Angel's the one that I'm like. Well, seriously, he doesn't use actual magic or you know.
I'm gonna give away this incredible 4,000.
Anybody can use a camera trick. I don't like the fact that he's misleading though with his fake audiences. I had this friend who was.
I think her phone died. She dropped off the.
Oh boy. Okay, well, hopefully she gets it back up. But no, I had a friend who was obsessed with Chris Angel, and I could never understand why because I knew him to be a fraud.
Oh, you knew him personally, or?
No, but I'm an independent researcher. When I get interested in something, I get obsessed with it, and I research the hell out of it.
I think her phone died. She dropped off the.
Oh boy. Okay.
Yeah, I watched him when he first came out. It was interesting, but a lot of the, you start to learn where they cut the, they cut the frames,
Yeah, no, I was captivated too at first. Oh, I'm getting an echo.
Oh, you knew him. And then, it's like, whatever, they keep cutting the frames and they hide certain things and they do like, they create illusions. They make a person look like they got legs and on camera, and then things like that. There's
Oh yeah,
debunking for these.
I remember this one where he supposedly pulled this lady apart in a park, approaching her. That's set up like he's approaching her. He doesn't know her, and it's all set up. It's all staged. The crowd that's around him when he's doing his little tricks before the big one. They're all actors.
Right. Yeah.
But no, there's some real interesting people. Like David Blaine does some real interesting things that I can't explain. But then again, he's crazy. Yeah, he puts his body through all sorts of intense situations that honestly I think he just does it for the wrong reasons.
Yeah, I mean, I had learned a few magic tricks that were shown to me that put me in a state of awe, and then I learned the trick, and I'm like, oh, that's easy. And then
Yeah,
I use
yeah.
it on someone, and they're like, oh my God, how did you do that? I'm like,
Yeah, no, I was really
so
into
there are
magic
those
when I was a
things.
kid, so yeah. And then when you learn how the magic works, I mean, it's almost like why didn't I
But here's
see
the
that?
kicker. I learned the same trick 2 decades later. I showed a magician. He was doing tricks, and I was getting fooled by all of them. And then I said, I know one trick. He didn't show that. He didn't do that trick yet. And I showed him the trick, and he said, yeah, I know that trick. And then he showed me another way to do the same trick that I didn't know. See, there's more than one way to do the same illusion.
Oh yeah, yeah, for sure. Yeah, I know.
It's a card trick.
Oh yeah, card tricks are very versatile like that, aren't they? I was studying magic when I was, a little kid. Like a lot of little kids get into
It's all
magic.
based on visual angles. What angle can you see at?
Yeah, sleight of hand. What do you can get away with hiding?
Where like they get your attention out there on their upper part of their body while they're doing something on their lower part of their body. Things like that.
I mean, if you would have asked me what this is that I built 10 years ago, I would have said it's magic because I wouldn't have understand anything about it. But it's amazing. Like when you don't know science, it does seem like magic, you know?
Yeah.
Yeah, I hope she comes back. I really want to take a look at those UFO videos. I'm really interested in that subject.
So that's topic of UFOs. Back in the year 2000, during the daytime, that's the only time that I saw something that had doesn't add up. Like
Right. So
uh, uh,
explain. Yeah, tell me about that. That's interesting.
so I'm driving on the highway on a Saturday. And I don't remember which month. It was the cold months here in Florida, winter months, probably February or something like that. And I'm driving and to do a communications job to move a phone system or set up a phone system. Hold on a second.
Okay.
And as I'm on the highway driving, looking forward, I notice it's like 10:30 in the morning,
Okay.
and you know how the sun is, orange and white color. In front of you while you're driving, you see that kind of a tone of light.
Sure.
So I'm just driving, I'm looking forward, and I see that tone of light change from as if a weird mixture of gas clouds covered or went between the sun and the ground. I don't know, but the light changed from orange and white, the normal sun tone light you see,
Mhm.
from orange and white, it turned to blue and silver,
What?
kind of like a bluish silverish tone.
Wow. That's
So
crazy.
And you know, it's just like that movie Starman. Have you ever seen that movie?
It sounds familiar. I might have when I was younger. Well, good. Just tell me
With
about it. Maybe remind me.
what's that actor's name? Jeff Bridges.
Jeff Bridges.
Okay.
Is
Well,
that
in
when
the end of the
you said
movie,
you recorded two sons at the same time?
I didn't record it. I saw it. I
Oh,
was
yeah,
driving. I
yeah.
didn't have any way to record it back then. It was the year 2000. I wasn't big on cameras. Even today, I'm not big on cameras, but I didn't have a camera then.
Yeah. I'm sorry, yeah.
But I saw it, and what I saw was, well, first I saw forward the light in front of me changed from yellow whitish tone to bluish silver as I'm driving, right? At like 10:30 in the morning on a Saturday. I'm like, why is the color changing?
Yeah, it caught
And-
you off.
Yeah, and I instinctively figured something's going on with the sun. Or maybe there's a special cloud or gases or something in between the sun and Earth.
Right.
And I look up while I'm driving, so I'm able to look up at almost a vertical position because I'm driving a Volkswagen Vanagon. And if you know what a Volkswagen Vanagon is, it has a windshield that's very vertical. Unlike most cars, it's got a degree of tilt, so you can't really look up without hitting your head in it.
Oh, okay. Oh, I see what you're saying. There's not a lot of
Right?
headroom there.
So I lean forward while I'm driving and I look up and I'm able to see pretty much straight up because of the car I'm driving is a Vanagon. It's got a very vertical windshield, front windshield. So I can pretty much see what is causing this light to come down. And I immediately said, wow, look at the moon. And I thought it was the moon at first, right?
Mm-hmm.
And what I saw was a perfectly round, now I'm going to quote the word perfect, because it was perfectly round. Like the way you look at the sun through glass goggles or whatever special lens, you see the perfectly roundness to it, right?
Right.
And that's what I saw. What I thought was the moon was, and today the moon is perfectly round, and today the moon is 10 times brighter, and today I could look right at it without being blinded by it. It's not that bright, but it's 10 times of the. It had to be because it's 10:30 in the morning. How are you going to see a moon that's not 10 times its normal brightness at that time of day?
Yeah, maybe it wasn't something.
It wasn't. That's the whole thing. It wasn't the moon because I don't remember any craters, any markings of any kind. And the last I checked, the moon is not perfectly round. It never was, and it never is.
It's crazy how these things happen in such a quick amount of time, and then
You don't have a perfectly 360-degree, angle or circle.
sometimes, I don't know. Sometimes if you see something crazy, like it doesn't click immediately,
So, and another thing is, this light object that was creating this blue-silver light was not. It was not at the 10:30 position or 10:40 by that time, whatever. It was like 10:40 something, 10:38, 10:40, around there. It wasn't at the 10:40 position. It was at the 12 o'clock position, and it wasn't 12 o'clock. It was 10:40. So how is it the sun either? It's not the moon. It's got no craters. It's perfectly round. The moon does not have a perfectly round shape to it. Okay. The sun does. And you know that when you look at it through the special lens. You see the perfectly round. It's always the same roundness. It never changes. That's what I saw with my naked eye. It was like looking at the sun that had been dimmed all of a sudden. But not only had the sun been dimmed all of a sudden, and here's another thing. The sun was nowhere to be seen. I did not see the sun when I saw this object.
sun, maybe?
No, I only saw one light in the sky, and it was not at the high noon. It was not at the 10:40 position. It was at the high noon position at 10:40 in the morning. If it's the sun at 10:40 in the morning, it's at the 10:40 position. It's not at the high noon position. The sun is at the high noon position at high noon. It's not at the high noon position at 10:40 in the morning.
Right.
So what I saw was at the high noon position at 10:40 in the morning.
What if you saw
Does that make
a
sense to you?
time dilation And so you saw 2 points of that time dilation at the same time.
Wow.
That's interesting.
What I remember before the light changed while I was driving, this is one thing I seem to remember. I felt awfully like comfortable, like driving in that particular moment, and
felt
at ease.
at ease and peaceful.
Yeah, I felt like very comfortable.
Huh. And that's also reported with strange sightings in the sky as like an overwhelming urge of peacefulness and calmness that comes over you.
That's all what I do distinctively remember. It just seems to just joggle my memory. That particular thing, being so comfortable.
Something that
only that comfort only existed just before the light tone changed. But as soon as the light tone changed, I don't remember any feelings of comfort or anything like that. I felt my normal, usual self at that point. I didn't feel extra comfortable. I just felt extra comfortable before the light changed. I have to specify that. Before the tone of the light, the sunlight or whatever. And what I also have to express here is that when I did look at it, and I'll get a little bit deeper into this, because I figured this out over the decade. It's been it's been 2 decades or more.
Right, yeah. Memory gets a little fuzzy over time. I know that.
Well, it took me about 10 years to accept that what I saw was not to fully accept it.
Yeah, yeah.
It took me 3 years after the event to begin to doubt, that what I saw was a craterless moon with a perfectly round shape and 10 times the brightness.
It's got to be like world-shattering almost, when you're not expecting to see.
Right, but after a 10-year12 years after this 2,000-year mark, around 2012 or so, I learned about dwarf stars. And a dwarf star is dim. It's a dim star. And this is scientific, the scientific cosmology or department, whatever. This is their modern theory on stars and science and planets and relations with stars and planets. They say the majority of stars are binary systems, meaning it's more than one. You have more than one star.
Right. Yeah.
Yeah.
Like,
the majority of planets out there have more than one star. This is the modern findings with telescopes and stuff.
Regarding UFOs, though, specifically, I know Dr. Greer emphasizes the difference between the 2 UFOs that you could potentially be seeing. And I think this is important because it does make sense when you think about it this way. If it is truly an extraterrestrial craft of some sort,
no, it was a dwarf star. What I saw. That's what I'm trying to say. It wasn't.
Oh yeah. I'm saying on the topic of UFOs in general. If you do see one in the future, if you look for scaffolding or pieces, because according to Dr. Greer, a true extraterrestrial craft will be seamless because of their manufacturing process.
So I recently heard somebody was maybe NASA, a new study that they're saying that there is a possibility that we do have a dwarf star in our solar system, but it's so small that we don't detect it well.
Yeah.
Well,
and then what's your take on Planet X too? I know there's supposed to be a planet out there beyond Pluto that has like a very elliptical.
It's in the redshift planet, so it's only seen in the infrared. The only the telescope that we have infrared, there's like 2 of them in the world. One is in the Vatican for sure, and then some other one, I don't know, but it's also under heavy security.
Interesting. One's in the
Your
Vatican.
eyes cannot see infrared. You will see nothing. You'll just see the blue sky.
Yeah, so, if you don't have an infrared telescope, like a deep space infrared telescope, you might not be able to see it, but I'm pretty sure that the only people that have one such as this telescope, are two entities on this entire planet.
Right, and if the planet has a very long orbit, then we wouldn't be able to detect it at all.
Exactly. So, yeah, I do believe in Planet X, and I do believe in that it does have a very extended orbital
Posted a link in
rotation.
chat.
But I think it just exists on a spectrum that is very difficult to detect in such distances. And, for like humanity, we've perfected two, and maybe a few, a bunch of probes that have infrared detection capabilities, in their instruments. How much is that available to the general public? Very little of it, and it's very scrubbed very well to, keep us away from the region where probability of planet, 9 is in the solar system.
Yeah, I know NASA.
Well, I can tell you for sure that what I saw was a dwarf star, because I not only saw it, but if you look into what the scientists say about dwarf stars, is that dwarf starlight is the most pristine light wave known to the universe. So it's capable of enhancing DNA, repairing cells, and all that stuff. Okay. Now let me tell you, when I looked up to look at this light for the 2.5 seconds that I was looking, because I was driving, I couldn't stay looking at it. I was on the highway. And while I was looking at it for those 2.5 seconds, what I recall feeling in my eye is very like as if squares and squares and triangles were passing smoothly through my eye without causing any pain. It was like a very pleasant feeling to my eye. So why do I say that? Because dwarf starlight is capable of enhancing DNA and repairing cells. So the light itself is healing. So maybe that's what I was looking at, a dwarf star. And it just popped out behind our sun. And that's what they say about this system, that it's behind our sun. And every now and then it comes out from behind the sun at a slight degree angle. And it's brief. And you know what? If you've heard of the Hopi Indians, they say that this happens around the turn of the century. That's when the most appearances of this star happens, is around the turn of the millennium. And I saw this thing in the year 2000. That's the turn of the century. All these things are adding up over the years. I'm just saying, and I've connected dots, a lot of dots. And it was all a blank for at least close to a decade. I couldn't draw any conclusions. But it wasn't a UFO.
That's a fascinating
it was a dwarf
story.
star.
I haven't really experienced anything myself that was too crazy.
Personally.
But I know some.
I don't think I'll ever see it again. I mean, other people have seen it. There are different places on the Earth that it pops out because you're at a different angle to it, which would suggest that the Earth is not perfectly round, or like it means. Because otherwise, you should be able to see it pop out in a lot of places, not just here and there on the Earth. It's like, and they're getting footage of it on video.
I know that yeah, and I know that NASA specifically supposedly has a whole like a division. It's probably just one or two people, but they have a whole division just for scrubbing photos of the moon and Mars. There was a story, and this is a part of what was it, the 2001 disclosure event, where there was like over 24 highly credible scientists, engineers, and military personnel who came forward and it's like, yeah, UFOs are real. We know they're not from here, at least some of them. We have replicated some of this technology, and it was one of the most mind-shattering conferences that never really got any publicity. And Mark McCandlish was there, and there was somebody who was talking about being at NASA, and specifically somebody showing them, hey, you want to see a cool photo? And is like something he got the impression he wasn't supposed to see. And he showed him this photo of this structure on the moon, and it was clearly like a mushroom-shaped buildings. And he's like, well, what the heck is that?
I've seen all that.
Yeah,
they have huge.
And the guy looked at him, he's like,
type
exactly.
structures, too.
So, yeah, there could be, structures on the moon and Mars, and maybe that's part of the reason why they don't want us to have anti-gravitic technology as well. It's part of the secret of
the monotheism philosophy.
Right.
The monotheistic philosophy.
I have a far-stretched conspiracy theory.
Okay, let's hear it.
You want to hear? All right. So
let's go down the rabbit hole.
All right. So I believe that they actually got to the moon, but they were kicked off the moon because they weren't
allowed to be there.
They weren't ethically responsible to be in such a place because their intent
Hey Sheeny, how you doing?
Their intent was more of somehow monetization, not exploration. So they sent them back to Earth, telling them whenever you can create a gene that has a better a purpose to be on the moon, then they are welcome. Until then, stay back on Earth, play with your little toys and your little, firecrackers and blah, blah, blah. But you have no footing here until you earn your place to be here. That's what I think.
This does align with some of the reports of the astronauts going up there and having an eerie, like they're being watched, like they're not supposed to be there, kind of feeling. Off in the distance, seeing a few UFOs, just kind of monitoring them and giving them this bad impression.
Some astronauts said that they were kicked off the moon.
Yeah,
Clear
that's
as
interesting.
day.
You know what? I do believe that there's a good
By
possibility.
who?
Right,
the Nazis from World War II or what?
Well, I believe that if there is sentient life out there, that they probably would quarantine us.
If
just
that's the
because
case,
of
we better head over there and grab their asses.
But they would quarantine it would make sense that they would quarantine our solar system until we learn to be responsible enough to use our technology to not destroy ourselves. Because that's like a virus. You spread from one galaxy to the next, and all of a sudden your, explosive technology is infecting other people.
They're the evolution of us. They're us, but just in a...
They don't approve of nuclear bombs.
That's all. Like, we see them as different, like we see them as aliens or entities or unidentified, but they're still us, because on a quantum level, if we are able to see them, communicate, see evidence, the anomalies, then they're in our gene pool, and that's the string theory of connection.
Yeah, definitely.
So we just have to, they're not hostile. They're on planet Earth to ensure their existence. Because if we mess up now, then they don't exist then. Understand?
If you look at the ring Earth theory, it's like the planet is way bigger than they tell us.
When the time changes, like when they come back to our frequency, that alters their structure, their biological tissue, their atomic structure, because they endured an extreme opposite energy to achieve. Like anything you're going against the current, it's like twice as much, or maybe more force to achieve that. And so they a lot of it they endure. So when they reach our frequency, remember they have endured a lot to reach here. So we assume that They're
Yeah, that's got to be a lot of energy consumed just to, if you're traveling back in time, I can imagine.
yeah, but what they do is they ensure that the core structure of the DNA molecule that has combined links for our species still have a connection, an energy connection, like a core, like, the seed of whatever, how, we
Sort of like a
become
quantum entanglement from now and then.
Yes.
Huh. No, that's interesting. But yeah, because time, is just an illusion. It's all existing at once in one context or another. We just can't perceive it that way.
I mean, we can in numbers and
that's true.
computations and faster computers, faster quantum computers we can bypass time from at
Now,
an instant.
With predicting that with quantum computing, is that just limited right now to predicting the states of quantum particles, or can we do a little bit more than that?
You've got two kinds of quantum computers. You've got your open source quantum computer, where it's like a cookie cutter. It's not, it's just it's a copy of what we currently have of information, and it gives you like generic random answers of the public information. But you want to go like deep, like actually access things that are not public domains. That one works on the higher oscillation atomic chips, the structures, and sometimes those are not available to the public because they're radioactive elements, for example.
Oh, really? Oh, wow. I know they have to be super cooled because I can imagine they get pretty hot, but I didn't know they had radioactive material in there.
Yeah, and so we won't be able to replicate anything like that. It has to be under a lot of parameters. But for universities or for government scientific departments, that's an open access for them because they're funding it.
Whoa, do you see that?
What?
Did you see that?
What happened?
I just saw it. Look at the video. They're capturing it. I'm telling you. It still shows up. It happens in a little bit.
Very nice.
Did you see it? Can you see my mouse?
I see it now, yeah.
The mouse cursor?
Yeah.
Yes, I see it. That like little green halo. Not halo.
See where the mouse cursor is moving around?
Yeah, it's definitely not a cloud. Definitely not a cloud. What is that?
Not the moon either.
Like could it be like a lens flare, like a lens
No.
lensing,
Not the way it appears.
Okay.
It just it's behind a cloud. It's right there. Can you see the mouse cursor?
Yeah, it's definitely not a part of this the forefront of the clouds. Like it's a different density.
It could be the moon. I mean, I don't know. Softly looks a little big to be the moon, though.
It's hard to say indefinitely, but there's definitely something weird going on there.
It's a dwarf star. It's not as bright as our star. It's 10 times as bright as the moon. Look how it got fully bright there at the very end. The moon doesn't just fully light up like that from being half lit. Right now it's half lit, and now it's like right at the end. It seems to fill up with light because it's behind a cloud. Maybe it is the moon. I don't know.
Well, I think this is an important lesson that we should all keep our eyes to the sky.
Amen.
There's one in the of two suns in the Empire State Building, but I can't seem to find it. They take it off the internet. But there's these, two girls on the Empire State Building with a camera, and they're 180 degrees apart. You see two light sources.
Yeah, some of the good videos get taken down, but I'm seeing a lot of good videos that aren't being taken down recently. Like, or I'm not hearing as many reports of, like popular trending videos being taken down. So I don't know, maybe that's.
I hear China's getting a lot of good captures of it right now.
Well, the more people we have capturing these weird phenomenon that they don't want us to know about, then the more they can't suppress it, and it'll just eventually just come out naturally, like a wave, like the tide. It comes and goes.
I figured something out. I kept on seeing aurora streaks.
Oh, this one's interesting.
In the sky. All right. Anytime
could be through a pane of glass, but
anytime I focus on a star, it feels like it's moving. Well, I'm like, okay, I know I'm not seeing things.
You can sense its movement, or you can see its movement.
I can see its movement.
Okay.
So I started researching. What I found out that planet Earth oscillates according to the magnetic field. So
yeah, like 7 point something.
Okay.
Hertz, right?
And by the way, when you see that ring around the sun,
maybe more.
Look at that.
Maybe more. So when the Earth is vibrating, I mean, we're talking like our bodies cannot.
Crazy. What the heck is that?
Oh my gosh.
Yeah, look at that.
You know why it creates that ring and that effect? That's because there's two light sources joined together.
Oh wow, like an eclipse.
Like two flashlights almost lined up.
That's insane. And you can only see that at specific times and specific parts of the Earth? Is that why it's so rare?
That's the dwarf star I'm telling you about. It's behind the sun.
But I mean, you can only see it at specific parts of the Earth, like
no, it depends. It depends how the two stars are moving in relation to each other. Because from the dwarf, the dimmer one is behind the brighter one, so you're not going to see the dimmer one ever unless it comes out from behind the brighter one at an angle.
Oh my God! If that
is real
footage, that's insane.
It's so pretty. It's so pretty.
It is beautiful.
Like the angle from behind, it's a dimmer light source behind the brighter one. And you're saying that this has
like a healing effect too, or a calming effect?
Well, I mean, according to science, dwarf starlight is the most pristine light wave known to the universe, and it therefore it's capable of generating lots of things, life and evolution, whatever.
Yeah. And then
if you believe in evolution, I don't know. I mean, or generating, healing skin and whatever. There's a Japanese scientist that did this with light. He was a billionaire. He also built the prototype, the high 300 mile an hour Rolls Royce.
Certain frequencies of UV light to heal skin, and it's not that if you believe in the principle of incommensurability, it's not that hard to believe we have stuff that damages us at certain frequencies. It's not unlikely to believe that we have stuff that's good for us at certain frequencies.
Right. Well, yeah, exactly. There's good frequencies and there's bad frequencies.
So the blue end is the good end, you're saying?
Well, a dwarf starlight is not high amplitude. So when you pump up the amps on your frequency, that's when it becomes harmful. Because it also starts to distort. So if you look at our sun, it's not a pure signal. It's got 85% of its clean energy. The other 20% is distortion and radiation, and that's why we have storms and all that kind of stuff.
And
And
I think Tesla described light as just like a sound wave propagation in the ether.
well, that's sonoluminescence. When you boil it down to one word, that's sonoluminescence, sound turning to light.
Oh, is that what that?
That's
Okay.
a scientific term for it.
Interesting.
So there's a theory out there that all the stars are made from sound waves, sonoluminescence.
Oh, that's fascinating. Yeah, I wasn't aware. I mean, I've heard the term before,
Yeah.
but I didn't know what it exactly meant.
I know sound wave can collapse into matter, so why not?
Right.
See, I didn't even put China in the keywords here, but right now China's getting a lot of the videos on the internet.
This is a new video that just was uploaded, or has this been around for a minute?
6 years ago.
Oh, it's not that old.
So you could sort by recent, right? Let me try that.
Oh, 6 years ago.
Upload date, yeah. Here's one from 4 months ago. Whoa, that's definitely not a pane of glass. Even if they're in a bus filming this through the windshield, I don't know. The way no. You know how the glass can create the effect?
Right. Yeah, the I
You
don't
can
know
kind
what
of tell
it's
that's not it here. Although maybe, I don't know. But yeah, I don't know.
So,
But I did see, the object I saw had the same form to it that you see here, and about the same brightness.
Dan says Eric Dollard is working with an ex-Lockheed Martin scientist, and they are releasing an anti-gravity vehicle. I would love to see that. I hope that's true. That would be awesome.
Can I be the pilot?
The thing that I worry about is people are such crappy drivers already. I wouldn't trust getting in the sky with somebody because I don't even trust getting on the road with them.
You know, like these devices read neural energy, so they're somewhat alive. So have the best of faith. You give it an extra positive charge for lift, because the difference between up and down is, you know, just the intent, where our energy actually, it gives it life.
And what was his name on the podcast? I don't remember his name, but he was talking about detecting at the Planck level gravity and anti-gravity, which was really interesting. And I forgot to mention this because Bob Lazar mentions an A and B component to gravity as well, a push and a pull.
So on this channel, the final days, she's been capturing using the NOAA public domain camera systems. She gets the footage before they remove it and puts filters to it and all that.
Oh, cool. So he just captures
And
it
she
all
has that right there. If you see that, that's Nibiru through filters. Can you hear the audio?
No, I can't hear the audio. You might have it muted. If you unmute it though, I'm gonna mute my mic. Is that actually a part of the photo? That round circle?
Yes. You use filters to
like
get the image out of it.
Yeah, the little square is just a filter to see it better.
Hang on.
Oh wow, that's crazy.
I've been following her channel for a while. I've never actually seen Nibiru because I don't have infrared goggles, but I'm probably going to have to do it one day.
So, you guys want to hear something really crazy?
Sure.
So, this is based off of this is something I based one of my own theories of the coil off of that I will be testing eventually. But Malcolm Bendel, some of his tests indicate that the carbon, I believe it's carbon 12, residue inside the thunderstorm generator is coming back testing like 12,000 years ahead of what it should be, like aged more than what it should be. And this indicates his theory that clockwise rotation within the thunderstorm generator is actually reversing time, and counterclockwise is fast forwarding it, accelerating it, and it's the time dilation is confined within the unit. But I had a theory that that if that's true, and the same vortex type mechanisms are happening in the coil, Daniel and Erica Nunez did report some healing properties by pulsing the coil on wounds. Now, I'm not suggesting anybody do that. I might end up testing that at some point if I can do it safely. But if that is true, then the reason why it might be healing, in my theory, is maybe at the vortex, it is either accelerating or reversing time. What do you think on that?
Yeah. I believe when we have gravity wells, they dilate time.
Sure. Yeah, that's a good point.
Gravity fluctuations. Yeah. So, and it could create different cloud formations where where the gravitational well anomaly is happening. So, yeah.
Yeah, I just thought that was interesting, and it's just a hypothesis, but yeah, if it's healing wounds, I mean, I'm thinking to myself, okay, so there's either a biological component, or if this time dilation effect is confined to, like the edge of the tor or, around it, maybe it's accelerating time in that vortex area where the wound is placed, and shortening the time it takes the body to heal it, because it's, fast forwarding time in that little space. I don't know.
That's an amazing idea.
Yeah, the more I think about it, the more I want to research it more.
We talked the other day that plants grow faster,
Sure. Yeah, Daniel.
So if the plant structure, is generating at a faster rate, it means you're speeding up time. Absolutely.
That's a good subject for the next stream. Maybe tomorrow I'll load some slides up of Daniel and Erica Nunez's experiments with the plants, and you can see like the edges of the leaves growing towards the magnetic field they had placed near it, and how the leaves on the one side are like really like they're healthy and they're standing up, and they report that the plants that they were growing grew like almost twice as fast. They were very healthy, a lot larger. In one experiment, they wrapped a coil, like an actual regular thick gauged coil, around a potted plant that was hooked up to the Rodin coil. So that would be an interesting and easy experiment to do with the coil as well.
Well, since we're like so brilliant, where do we start?
Yeah,
where do we start to, like actually scale this up to, achieve faster time, like contracting space and time to make things go faster.
So Daniel and Erica Nunez had an idea about how to make one of these things into a house. It was almost like a half toroid shape. I could put that in the slides tomorrow. I'm not sure if it goes underground. I didn't take an extensive look at it, but my idea is if it's doing an acceleration or reversing of time within the vortex, it would be contained to that vortex. And if you make one big enough where you can enter the vortex, I don't know what the effects would be on biological matter, but I mean, you can imagine a situation where, we could build a time machine theoretically.
Could we use a trampoline? Think about it. The structure of a trampoline. It's round, it has an elastic, it has coils. If we run a circuit through all of that, it's, it has evenly distributed axes. And it's aluminum, and you could build off, like you could add additional parts to it to frame holes. I mean, think about it. Like, we could build something.
That's interesting. Well, I was thinking about that the other day of how to scale up. How would you wind a giant Rodin coil, right, with a very thick gauge wire? How would you manufacture something like that? And if we maybe are able to scale it up and reduce the fractal scale of the winding pattern to like maybe a star or another more simpler geometric form, we might be able to get away with doing that with a trampoline, because there are flat versions. I'm sure you're aware there are flat versions of the Rodin coil that use they're like less precise fractal geometry of the vortex.
Think about it. It's pre-drilled for the little coils, so it has like a lot of little.
No, it would make a perfect frame. It would make a perfect frame.
I mean, it's kind of a thought that
No, that would be, if we wanted to makeshift something like that, that would be a brilliant idea to start with the frame, at least. Because manufacturing those big parts, or at least for somebody like me, is virtually impossible. But going out and buying a trampoline and disassembling it and adding stuff on it, that's easy.
I'm telling you, it's like $100 for like 16 feet, and diameter is nothing. And like, the stuff that comes with it, if you want to go buy it separately, like, it will cost you maybe 4 or 5 times as much. I personally, this is where I get my ideas of inspiration. Different objects that I could see a different use to them, or make them into something like an invention. You don't know how many, anything that breaks, whatever. I keep all those electronics. All of them have like the little parts that I need.
Yeah, I try not to throw out any of the electronics I have that break anymore, because I realize that I could be utilizing some of those parts.
Like camera lenses. Those are like optical discs. Go buy one right now. You'll pay like a couple $100 for something that was attached to something that cost maybe a fraction of that.
Most people will throw it away or replace it if like a capacitor blows on the circuitry inside and they can't use it anymore. Anyway, Daniel Foster. Oh yeah, totally. I'm in too. Daniel Foster said that there is no time in my field momentum cab. Teleportation resides centrally within the superconductor gravitator
Most people will
cores.
throw it away or replace
I'm
it
getting
if,
some
you know,
echo.
like a capacitor blows on the circuitry inside and they can't use it anymore. Daniel Foster. Oh yeah, totally. I'm in too. Daniel Foster said that there is no time in my field momentum cab. Teleportation.
Yeah, I'm getting a little echo.
Right.
The superconductor gravitator
Oh, there
cores.
you
Throw
are.
it
Sorry.
away.
Go ahead.
Oh, there we go. So yeah, tomorrow I think I'm gonna load up some slides for everybody to check out some of more of Daniel and Erica Nunez's work. I have a lot of not a lot, but I have a decent amount of stuff that most people haven't seen, just because
I don't know how I did it, but I found that unlinked page on their website, so I just grabbed everything I could. I even have a bunch of text documents that I copied and pasted into, you know, the notepad or whatever. So yeah, I'd like to get into some of that as well. They have some pretty cool stuff, some pretty cool videos that I think most people haven't seen. Some of them, like most of them, were taken off of YouTube. All of them off of their channel, but some of them are still, like, you see a couple of them here and there on other people's channels that they've reposted them, and there's like maybe one or two on Venmo, and then a whole bunch of clips on Instagram. So if you go to First Stop Energy's Instagram, they have a treasure trove of a bunch of, you know, posts and short video clips and a bunch of fun stuff that, if you're interested in their work, I highly suggest you checking out their Instagram.
I still haven't gotten into the Instagram.
Oh, I haven't either. Trust me, I try to limit myself on social media nowadays, especially since Facebook destroyed me. But
what's that? Telegram, Instagram?
Yeah, Insta whatever. Now, I completely disabled my Twitter account, or not? Is it Twitter? Yeah, the one that now is X, but you know, somehow we've rebranded, but we failed in our rebranding because we have to mention the fact that we've rebranded.
What do you mean you got a brand or like a logo or something?
No. So you know, Twitter, the platform that Elon Musk now owns, he rebranded it to X. But every time you see X listed anywhere, it says X parentheses formerly Twitter. If you have to do that every time to remind people that you rebranded it, you failed in your rebranding. Like that's marketing 101. Elon Musk is an idiot, so let's not get me started on him.
So he kind of like promoted himself while screwing everybody else.
Yes, he is a con man, in my opinion. And
on the promotion anyway, he made it so everybody else had to redirect their promotioning logos and all that.
The thing that I most don't dislike about Elon Musk is he has a huge team working on all the projects that people give him credit for solely, and he never references anybody else for credit. He never corrects somebody.
Final days. Today is Tuesday, August 15th, 2023.
Is that Fractal Woman?
Today we will be viewing FAA weather camera videos that show two
Final Days
planets
channel
in a stable
the
orbit
channel,
around the Earth.
this
We
lady,
will be
she's getting all
calculating
the
the approximate size and distance
weather
of one of the two planets.
cameras that are stationed around the planet.
The Lord wants me to share some very important
And
words.
she's running filters behind them to bring out the Planet X.
The purpose of this channel is to show viewers that we are living in the very last days according to the Holy Bible. Our first set of images was taken by the
You still there, Ben?
Hannah, just the day before yesterday.
Yeah,
on August
sorry,
13th.
I'm just trying to adjust this so people can see this a little
on this
better.
map, Sealy Lake is located in the northwestern quadrant of the state of Montana.
I put the link in your channel.
Each image in these videos is 10 minutes apart.
Where is it?
We don't see much here in these images because the atmospheric chemicals in this area
Daniel
of
said
Montana
only a moron takes
are
rockets
so
to Mars
thick
for
that they are blocking out everything that you and I are not supposed to see.
I agree.
Even with contrast applied, it's difficult to see the large, close planet that's actually right there, smack in the middle of this image. In the last few frames,
I've been watching her videos for probably 5 years now. She doesn't post as much anymore, but what happened?
Welcome back to the Missoula, Montana video. Here we see a very detailed celestial object with a fast rotation and very obvious craters. We know this cannot be a lens flare of the sun because of its fast rotation and heavily textured surface. These are signs that we are living in the very, very last days. We're living in the very last
I think her
minutes
outlook's a little
of
bit
the last
negative, but
days. This object can be seen from many FAA weather cameras, including Mississippi,
Yeah, I don't know about that
Colorado,
last days
Alaska,
part.
and
According to the
other
Bible, nobody
FAA
will know when
camera
that happens.
locations, as we've seen in the past.
yeah, everybody's
several times.
been saying it's the end of
This
time
object
for
was
the end of
proven to
time,
be
pretty much.
between the
No,
moon
nobody's
and
gonna
the
know when that
Earth
happens.
in our video from February 5,
least according to the Bible.
2022. It is eclipsing both the moon
I put the
and
link
the
to her
sun
channel
daily, as shown
in
in
your
that
channel just
video
now.
from February
okay,
2022. That same video explains in detail how daily eclipses occur, but no one sees it. Here's a close-up of
Right,
that
it's infrared. You
same
can't see it with your
viewed
eyes.
from Missoula, Montana. Notice that many craters
So most people just don't see it.
to the height of the crater
You
mountains
take
in
a
this
picture and
image.
put in a filter, and it's
It
just
would
there.
make sense to say that this object is
Yeah, well,
less
if
than
you have a
half
way
the
of,
size of our moon, perhaps
you know,
about
like photo
1,000
editors have all
miles
these filters.
Oh
they
yeah,
can-
yeah. I'm just saying, like it
1,000 miles in
blows my
diameter.
mind, like that people are
Our
just
moon is
unaware that they're,
2,000
you know, like
The Bible says that
living about their days and they
judgments,
can't see it.
plagues, as stated repeatedly throughout the Bible,
So she found a way to run filters with her editor to bring it out
either while
from
we
the
are
original
here,
photo from
or he will
the
take his
public
faithful
domain
followers
weather
out of here, which
photo
is
stations
also
that are
called the
posted
rapture.
here and there, you know.
We have
And
God's
they
promise
delete
on
these
this in
photos,
many places in the Bible.
but she gets them off the
The
servers
New
before
King
they delete
James
them.
version
I wonder
of
why
Luke
they would
chapter 1,
keep that
chapter 21,
secret.
verse
If this is
36
true, I
reads,
wonder why the secret
"Watch
on
therefore
the dwarf
and
star.
pray always that
Then
you
because
may be
everybody in the
counted
world would buy an
worthy
infrared
to
camera and start
escape all
posting the
these
videos as well, and then
that will come to
they have to
pass."
change the entire scientific
Jesus is referring to God's
history.
wrath.
Yeah, and say
He
like,
is
oh,
saying
sorry
that those
guys,
who are counted
we're
worthy
advanced, but
will
we forgot to
escape
tell you
all
there
of
was a
God's
star here
wrath.
in our.
The Bible specifically tells us that God's faithful followers are not appointed to his wrath. To be counted worthy
Now, I would
to
not have
escape his wrath,
I would not have
we must
concluded
be
that what I
living in
saw that
holiness.
year in 2000
A
was
link
a
in the
star if I
description box
didn't
below
have the
discusses
memory
what holiness is
of
and
having
how
a
to
pleasant
achieve it.
feeling on
Just
my
click on
eyes
the
when I was
More
looking
link
at it.
below
And also I
to
would not
read
have,
the to get to
concluded
that
that
link.
if I didn't learn later about
The
dwarf
following
starlight
screens
and
list
how
things that
pristine the
Bible
light wave
tells us
is.
are sins.
So it's
And
that
then after
pristine that,
screens will
you
tell
hit some water with
how
it
to accept
and the
Jesus
water probably
Christ
turns
into your
to,
life
you
and
know,
avoid the wrath of
nutrifying
God.
amino acid proteins or
Thank you
something.
for
Who
watching
knows?
this video.
Well, you
But
know, the thing that I've kind of learned over these last couple years is
it's a pristine frequency. It's a very hard frequency
I don't
to
think there's
create.
any coincidence. So, you know, the universe tells you stuff. The universe sends you signs all the time. Most people don't know how to listen. But, you know, I think anytime you want to use the word coincidence, just take a step back and reevaluate the situation. You know what I mean?
Yeah, I wish I read more of the Bible like she did and all that, all these holy books and stuff. They contain all these historical events in them.
And not only that, hidden knowledge, according to Marco Rodin, who developed 4-dex math, according to him, he didn't discover it. He rediscovered it. This math is in the Sanskrit text. You know, it's something that was lost in time. But yeah, he studied all sorts of ancient literature, like basically all the major religions, Buddhism, the Quran, the Torah, the Bible. He studied it all, and he said that it always comes back to these certain themes, and it's about it's about God and numbers.
Both of them. This celestial object is the center of each crater is a white plateau or mountain created by the
This is one of her
impact
recent
the
videos.
asteroids pummeling the surface of this small planet or moon.
Let's see what.
Take notice of the approximate
2 years
height
ago.
of these white structures. They look very high. That's
No,
why
10
they
months
show
ago.
up as a
Sorry,
large white
10
dot
months.
in the middle of each one of these craters. They're very high. And they have to be high in order to show up on these FAA weather cameras. This same thing happens with craters on our moon. Notice the approximate height of the mountains or plateaus in the center of the moon craters. It's important to notice they are not nearly as high as the top edge of each crater. These structures are located in the center of each crater, but are not nearly as high as the mountains in the center of each crater on the image from the Missoula, Montana FAA weather camera. These crater mountains can give us a rough estimate of the size of this object. The smaller the celestial object is, the lower its gravity, and the higher the mountains inside the crater. Small planets have less gravity than large planets as long as they are similar in density. Thus, the height of the crater mountains in the center of the craters on a very small planet would be much higher than the height of the crater mountains on a much large planet where the gravity is much bigger. Knowing this, we can deduce that this object is much smaller than our moon if we compare the height of the moon's crater mountains to the height of the crater mountains in this image. It would make sense to say that this object is less than half the size of our moon, perhaps about 1,000 miles across, 1,000 miles in diameter. Our moon is 2,159 miles wide.
What is this object?
Here is the same celestial object over a 21-month time period.
She never said what it was. Most assumed, I assumed, following her channel over the years, that it was probably the Kachina planet. But around this supposed star system they call the Kachina star system, it's a star. The Kachina is a star that the Hopi Indians predict comes around the turn of the millennia. And it has planets around it, more than one, planets, plural. So the largest planet is Nibiru. So that means, based on what she's saying here, is she's kind of suggesting it's not the largest planet. I don't know if she's suggesting.
She's suggesting it's not in our solar system, but it's another one, another solar system.
No, it's in our solar system. It's close to us.
Because you're saying it has other things around it orbiting it.
Well, so the Kachina is a star. It's a dwarf star. It's a very small, dim star.
I know. Is it orbiting like our solar system, or is it...
The trajectory that they came up with, NASA or whoever, is that it's elliptical, and it's like 3,000 to 4,000 years elliptical orbit around our sun.
Our sun. Okay, got it.
Yeah, and supposedly it went around our sun in the year 2012. Which makes sense because if you know about the blue redshift with the Hubble telescope, now objects that are coming towards you from deep space will have a bluish shift in color. Now, going back to my sighting in 2000, what color did I say it was?
It was blue, right?
Blue?
Yes, bluish silver. Now, objects going away from you are reddish. Now, after the year 2012 or around that year, I don't know exactly, but it's the captures are red. They're not blue anymore because it went around our sun already, and now it's heading back out away from us.
Interesting.
But it's been coming towards us probably since before the 1950s. At least, well, it's been coming towards us for like at least 15,000 years, 1,500 years, maybe 2,000 years since the last whatever. And it got close enough to us within the last 50 to 100 years to create a temperature differential.
So
and now we have phrases like global warming climate change and all this crap.
And you're saying the 2012.
I'm saying the dwarf star is responsible for the global warming, nothing else.
But back to 2000.
It's closeness to us.
That was its apex of its orbital. Is that what you're saying?
Yeah, it's closest. Back? Its closest point. Yeah.
Oh, see, that's interesting. And
no,
the Hopi Indians and the Native Americans, they are very wise. I like to listen to ancient cultures like that. Honestly,
I've heard of them. I've never really took them by all their what do you call it, foresights or whatever. I just listened to it. I never had any understanding of any of it. But I came back to them again later when I ran into the dwarf star, and it just seemed to link up the only predictions of a dwarf star, because I found out that what I must have seen was a dwarf star, and then I started searching dwarf starlight, and then recent. Yeah, no, it's just like the only cultures that speak of a dwarf star is the Hopis that I know of. Probably the other cultures, and I guess the Dogon in Africa.
You matched it up on the timeline and the astral timeline. Right? Like, because the sky changes every so often years in the depiction of like ancient artwork, they always, use the stars as the to tell the time period of, on Earth by the artwork.
Summarize it as this. Yeah. I throw out the fireball theory, sun, like you're gonna burn yourself kind of thing, I throw that out. I throw it out. I don't regard it. I regard any theory that suggests that the sun is a plasma, a spherical, a perfect sphere, plasma, just like what these people are filming now. These little ball lights. I've seen some videos of that, by the way.
So the actual structure of plasmoids is more of a donut shape. For a lot of there's different shapes, but like the ball you see is
but what you're going to see is a perfect sphere.
Right,
maybe shaped like
the corona discharge, but its actual structure is more of like a donut. So what if that's maybe the shape of the sun, and we just are seeing the corona discharge, obfuscating it? I don't know.
Yeah, like it's the focal point. It's
right.
It is, the sun is the focus point, and the focus point is being shifted with the wave pattern, the wave field, the movement of the wave.
But that's
I've heard of that the sun has a hollow center, and it I've heard of this before. So
that goes.
So I mean, if you throw out the fireball theory. If you throw out the fireball theory and you accept that the sun is formed by sound frequencies, okay,
which cavitation bubbles can be formed by sound frequencies, and
if that's your way of thinking, and you see it like that, then to have more than one light source form is not so far off.
No. And like she said, if it's hollow, a donut shape or a torus shape is hollow.
Because you're not depending on two fireballs now. You're depending on the two sound waves, and that's easier to conceive because we already know there's way more than two sound waves flowing through our atmosphere.
Right.
From all kinds of directions, from all angles of space. From stars we cannot even see.
But
they're ejecting waves that we can detect
words you use is
right through the planet.
The choice of words, focal point, is very interesting that you use that choice of words, because that's what.
Yeah, I saw a video where they termed it like that.
To the sun as a focal point for.
It could have been one of his videos that I heard that from.
Yeah, and.
But I tend to agree with, if it was Malcolm Bendall that I heard that from, I just tend to agree with.
The theory,
the wave pattern.
It makes sense. No, everything you're saying makes sense, and
the sine wave,
and it does align with what Malcolm says. So, I tend to lean towards Malcolm's theory more than other unified theories at this point, just because.
But here's the kicker
he has
of
practical
the sine
application
wave
for it.
thing. Here's the kicker of the sine wave theory. You take a circle, right?
Okay.
And you cut it down the middle, and you move one arm to the right, and you have a sine wave. You have two half circles, one on the top, one on the bottom, from left to right, right? A bottom circle on the left, and the top has the half circle on the top. That forms a sine wave. And that's how the sun is moving every day. It's going up and down. Like it's moving in a curve fashion, but it's curving up and curving down. Like the pyramid. You look at this horizon, you see the sun go like just like do like a triangle up and down. It's more. It's really a sawtooth wave or just a sine wave, you know, however you want to look at it. But it's a sunset and sunrise right there. How would anybody else explain sunset and sunrise? They would explain it by a turning ball and a stationary, or at least from our perspective, a stationary light source. Of course, that light is not stationary, but from our perspective, it is, because we're gravitationally locked to this fiery ball of mass. And why does mass have to exist for there to be a gravitational lock? I don't agree with that. You need. I'm sorry. Why does matter have to exist to have a gravitational lock?
So
the sun is. They're saying the sun is matter and mass. It's full of helium matter and.
According to Ken Wheeler's theories on the secrets of magnetism, which is a really interesting book. I haven't read it, but
you only need mass for
Ken Wheeler's theory. I actually have a playlist where Fractal Woman breaks his theories down. But his theories on magnetism are that gravity is actually caused by a pressure differential in the ether. So instead of one object attracting another, it's a pressure differential that's being created.
Right. And mass is just energy mass. It's not matter. So the more energy you have, the more pressure you have.
Mm-hmm.
I mean, mass is just it's not matter. It's energy, right?
Mass is gained by velocity. You gain mass,
which is another form of energy.
Yeah, like things gain mass the faster they go.
So, I mean, light has a lot of mass to it. And that's why it can generate gravity. And potential, because it's got the mass. So it could be just the stars or the star light. The light effect is amplifying the mass, therefore the gravity localized to that light source of extra mass. Because you have pressure differential in the entirety of space, but where the stars exist, now it's like a differential between that star and the rest of the galaxy.
We never take into measurement the space between, like, the bubbles of two different galaxies, that space in between them. That's, we assume our space is vacuum sealed space, but really it's floating with particles like atoms, but the space between solar systems, it becomes a true void. Like there's nothing there for light.
A solar system is probably nothing but an eddy current in a larger swirl.
So that means light is instantaneous from one end of one end of a solar system to the beginning of another one, because it doesn't bounce off of anything.
The electric universe guys,
yes,
they have a great theory on that.
You understand what I'm trying to say? Like there's not any hydrogen atoms to like there's nothing. So it's just like a teleportation kind of thing from the edge of one to the beginning, the edge of the second one.
Well, I mean, I've never been in space. I have to take the word of the astronaut that there's nothing in space.
Okay, so listen to this. Listen to this. Voyager 2 has, left our bubble. Now it's in the space between. When that occurred, NASA lost, like the deep space network lost communication with Voyager 2 for, months, right? And they kept on trying to find the signal. Nothing. I mean, for months they thought that the craft just went silent.
And then the craft went far enough to reach into another bubble that was somehow connected to our bubble.
No, our sensors, like it shifted it into a very, very high frequency rate. Because now it's going
we
faster
did that,
than
or
the
sensor on the Voyager did it by itself.
Like the sensors, like like it was communicating back with the deep space network, but they didn't have that spectrum on as an analyzing tool for that kind of spectrum. So whatever.
How did the Voyager know how to change its frequency?
They had to send it a command frequency that matched how it's oscillating, that existence that it's in. You understand? Like they had to send the very high energy pulse of data, like stronger than what they were, stronger than what they were using, on hydrogen.
Oh, so they amped up the batch
I don't know
file
what they did,
burst,
but I know
the
they
data
did
burst.
it was something that we didn't have yet the capability of
Okay, I see what happened, Noel. They couldn't get through the bubble, so they turned up the volume on the batch file signal
yes
to get it through there, and eventually it got through. But they didn't have the right frequency to get through.
They had to change
so
the
they just turned up
module.
the volume.
They had to change like the command units on the module. It's really complex, but beyond
the module on the Earth base.
No, the command code on the internal motherboard of Voyager 2.
Of the Voyager.
Yeah.
So Daniel says
beyond amazing.
Daniel says there's 3 types of gravity. I don't know if he wants to elaborate on that. I'd like to learn more about that, if that's true. And also he asked if anybody in here is a musician. I personally play the piano and the guitar.
The image on the left is from the day before yesterday.
I play guitar.
Oh, nice. Now let's start a band.
1 month ago in November of 2021.
You can do a band on StreamYard, I got a plug for my computer, and I can play right into the computer.
Oh, that'd be fun to get on the keys again. It's been a minute. I haven't played in a while.
You gotta check out the loop station.
The loop station. There was this what was it? There was this app that allowed you to play, like join a group of musicians and just join and jam with them. What was it called? Jam?
What?
Jam Kazam. That's
I
what
gotta
it
check
is.
that out.
Yeah, it's called Jam Kazam.
And what?
It's called Jam Kazam. It was really buggy when I first used it, but maybe they've improved it.
Jam Kazam.
Jam Kazam. Yeah, and it's like you can create lobbies and set up your equipment with people and jam live with them.
I think StreamYard's probably more steady than that.
Yeah, it was really unstable, honestly, when I was using it. It was a cool idea. It had a lot of cool features for musicians, but it just wasn't usable, and that's why I didn't use it. I mean, obviously, it was bad. I mean, I guess it might have worked really well for people who could just plug in a guitar, maybe. But as for the keyboard, it was really.
Or a drummer, you need all these mics and phones and all that stuff.
That too, yeah. So, but I had a friend who used it, and I don't know.
supposedly he got it running at some point, but I could never get it running.
To hell by rejecting the Bible.
This is a recent video by her, and she's saying that this is a very small planet. I remember her mentioning that once before.
That neither life nor death.
So that means there's more than one, because Nibiru is supposed to be the largest planet around the star, and it's huge. It's like 40 times the size of planet Earth.
Now, is that the planet that's supposedly beyond planet Pluto?
While they lived on this earth.
It's one of the planets that are orbiting around the dwarf star Cassini.
And that, like in the far, like beyond the Kaiser belt.
That's the elliptical orbit star Cassini.
Huh. Because I believe that's the same planet that the Anunnaki referred to. Or the planet.
Well, that's where
the Anunnaki came from.
Don't the Anunnaki have their own tale of the death of the Christ and the rising of the Christ and all of that?
You know, I'm not sure.
And Ishtar, isn't that from the Anunnakis?
I'm not
the Sumerians.
Yes, yes.
Is it?
Yeah.
Ishtar.
Yes.
Easter.
Ishtar. The original name is Inanna.
Right, that's Easter. The rising and the death and the rising of the death of the dead and all that.
The queen of heaven and earth.
Yeah, the sun sets and sun rises.
I love that. I mean, people call it mythology, but I don't think it's mythology when you have real evidence of that civilization.
Yeah,
I mean, we have.
I think at the very least, maybe
the Sumerians write about the Anunnaki.
Yeah, but I think at the very least there was some components to that tale that was mistranslated, because now that I think about it, why would they come here to enslave us to mine gold if now we're finding that we can synthesize gold with alchemy? So something got mistranslated in that text, or maybe they're not telling us the full story, but it doesn't discredit or mean that it didn't happen or it wasn't real or based off of something real. But that's something that I've been thinking about lately.
People using these QR codes a lot, huh?
Hey Charles, how you doing? Welcome to the stream.
In many places in the Bible. The New King James Version of Luke chapter 21, verse 36 reads, "Watch therefore and pray always that you may be counted worthy."
The sound of the seers.
All these things that will come to pass. Jesus is referring to God's wrath. He is saying that those.
Yeah, I don't think it's all doom and gloom just because there's planets out there we can't see, and all of a sudden we have equipment to see it. Just. Dude, you're talking about the cosmos. There's nothing.
Well, I mean, if we based all of our science just of what we could see, then we would know absolutely nothing.
Right, but look at our technology to be able to database anything. It's been horrible. And now that we're getting good at it, we can, see things like this here, And
yeah, as technology gets more advanced and in the hands of more people, like cell phones, before that was a thing, there was, far less videos of UFOs and other aerial phenomena.
It's got a high definition camera on their phone, and they don't go anywhere without their phone.
And I absolutely hate this argument that you hear from like Neil deGrasse Tyson. Oh, why don't we have any high quality photos? Well, our videos. I'm like, well, you try capturing on your iPhone. I don't care how good that camera is. You try capturing something at 1,000 miles or 1,000 feet away, 1,000 yards away. Like, it's not going to come up clear, no matter how good your camera is, unless you have like.
Yeah, because they make these phones to zoom in a certain way, so they don't.
Yeah, the lenses are made. They're good for close-ups, but if you're trying to capture a UFO at like like a distance,
you need a 33 millimeter camera with a manual zoom.
Yeah,
manual optical zoom.
And shame on you, deGrasse Tyson, for you should know better. You should know that this technology is limited.
You need like a $15,000 Nikon with a high quality, high frequency definition zoom, meaning just the slightest. You get every degree of that zoom in high focus. That's a very high tech lens equipment.
Yeah, for sure. Yeah,
Now, like in the Hollywood now, they created a new camera now. I don't know, I remember the name of it, but the 33 millimeter camera was used to film like Space Odyssey 2000, or like any of those famous Stanley Kubrick films. But they created a new camera now, like where you can stay in focus between a person who's 10 feet close, 10 feet in front of the camera and 50 feet away from the camera. Now you can see both of the people's faces perfectly in focus. Whereas before, you only see the person's face that's closer to the camera in focus, of the old recordings of movies and stuff. You see other people's faces slightly out of focus as they're further away from the camera. Well,
Right.
they got across that problem with the optic technology.
Yeah, these cameras are getting really high tech. I know Corridor Crew just recreated some kind of crystal that they used in an old Disney setup that they haven't literally used since, and it's supposed to capture light in such an accurate way that we're wondering why isn't it being used. I guess the manufacturing process for the crystal is very hard to make. So, but it's interesting. But again, it goes back to geometry. It's the geometry.
Right. If you're able to, capture all of the light and all of its angles of projection from the source into your lens, you should be able to see in 3D, 4D, all that.
Yeah, and we had a company that had technology. I don't know if it's still being developed or why we haven't seen anything about it since, but it's basically a projector that can project 3-dimensional images without a screen, like in 3-dimensional space, like a hologram. I mean, I guess it basically is.
I heard that was coming out. I heard that tech was already out.
Is it? Yeah, so I haven't heard anything for a few. It's got to be like maybe 3-4 years. Maybe it was.
I heard about that coming out about 3 years ago.
Maybe it was augmented reality, and that's why I never paid attention to it. I found out.
No. I heard from someone I know that they're coming out with exactly what you just mentioned: the 3D hologram projector without a screen.
Yeah, I mean they're
using
if you listen to some of the military whistleblowers, supposedly the military has had hologram technology for decades.
They're using a special film, layered film to the projection comes off the film. It's the projection is hitting the film with a micro projector, to make it bigger.
Daniel Foster says gold is a cold fusion waste product. That's very possible. I mean, plasmoids have the they have the tendency to draw in matter and convert matter, and then kind of poop out other materials.
They came up with some kind of special, how like the liquid crystal display technology and all that?
Mm-hmm.
Something to do with that. They were able to modify that to create a 3D projection, like you mentioned, without a screen, like straight into the air.
That would be really cool.
You can also, you ever seen those hologram toy kits? You never seen that?
No.
Hold on. I bought one of these because I had to see it. $10 or $8, they go on sale.
Holographic gaming. Yeah, I had a Virtual Boy. Unfortunately, I don't have the power plug for it, so I can't use it anymore. But that was a pretty fun toy.
My uncle gave me that. Dibs, hat tip to the uncle there.
Oh, let me see.
So I was just looking, and I have this these spare parts from this Tesla coil that I never got working, and it has a coil. It has a the primary coil. So it has the iron core and all that. So I should be able to use that for my setup, huh?
Can you see that?
You said
I
what?
got one of these. This is the hologram toy.
Oh, I've seen those. I've never seen one in real life, but I've seen them online.
I had one in real life, man. I'm telling you.
Yeah, it's you put a little.
It looks like a real frog, man. You try to pick it up with your hand, and there's nothing there. You
Yeah,
cannot
that's
tell the
crazy.
difference. You cannot, and you don't need power.
Yeah, it just uses refraction of the light, right?
Yeah, look at that.
Yeah, that's insane.
I did that myself. I'm like, what? You cannot tell the difference.
Yeah, and it's.
Do you see that thing being powered by anything? No, there's just a
crazy.
reflective dish at the concave dish at the
So
bottom.
I guess the hologram technology would probably operate off of that same principle, huh?
Yeah. Yeah. Mm-hmm. Yeah. So they must have found a way to, electrify this principle and magnify its ability with some kind of a miniature. Man, I don't know. Maybe they changed the shape of the concaveness at the bottom and they project a image there or something. I don't know. Because I know you can change the hologram. You're supposed to be able to change what the image projects by loading a different image, and it just makes a hologram. That's
crazy.
This is so cool. Like, what you could do with that. Like, I mean, I'm imagining a scaled up version on the ground, and then you project something into the sky.
Oh wow!
And people would see
Right. Exactly.
feel.
Now what's the moon? What is the moon?
What
Is it
shape
real?
would that refraction need to be for the for the hologram to be at that
hold
distance?
on.
It's a ratios game.
What's the moon? Okay, you heard of David Byrd? I'm sorry, Admiral Byrd?
Yes. Admiral
Okay,
Ebert,
what
yes.
did he say? He went to the North Pole. He found a big hole in the ground. A big hole.
Yeah, the inner Earth.
Yeah, his
theory.
story is crazy. It's so
and
cool.
What does the moon look like when you look at it? It has a bunch of craters on it, right?
Yes.
Okay, now, if you're on a planet and the center of the planet is a toroid, where's the greatest force of energy or a gravitational field? In the center, right?
Yes.
And if you're on that planet and there's rocks in space coming towards you, where are they going to land?
On the craters?
They're going to land in the center of the toroid. Now, if the center of the Earth is the North Pole, and that's where the hole is that Admiral Byrd found, he filmed it from the plane, it's a huge...
So the toroid is where the poles are.
Right. Now, if the North Pole is the north side of the toroidal magnetic field, and that's the hole there, and then you have another hole in the south, well, whatever. Let's say that at the bottom of that hole, there's some Earth.
Is this
and
going
not only
into
that,
the hollow Earth theory?
Yeah. And not only that, inside that hole is where the greatest gravitational force is taking effect for the entire planet. So the majority of the gravity is focused in there. So now, the rocks coming from space are going to land where? The comets and the asteroids, where are they going to fall?
I would say in the
In
south
the area of
side.
the greatest gravitational field, which is the hole.
Oh.
And at the bottom of that hole, there is some ground, and they're hitting it, and they're creating craters. And that hole has a light source rotating around it,
Yeah, but the
and it's
moon is
projecting the
orbitally
bottom of the
locked.
hole with the craters. And
But
you
the,
see a moon with craters
yes, but we only see
moving
one face
around
of the moon
the
all
Earth,
the
just
time.
like the sun moves around the Earth. Because the sun is creating the hologram of the bottom of that hole. And that's the moon. That's my theory.
I see what you're saying.
I can't deny that being my theory, because it is. After looking at this device 100 times, I came to that idea. I said, man, and I connected the dot between Admiral Byrd and the hole, the Earth's the center of the Earth. I'm thinking, this device right here operates the same way. It's reflecting whatever's at the bottom. Now, what if the bottom is nothing but Earth soil and a bunch of craters, and there's a light going around that? It's going to create a hologram up above, and it's going to move with the light. So if you move your body around that device, that hologram moves with you, so that from your perspective, it looks like it's standing still. But it's actually moving to adjust to the light reflection of your eye. It's pretty insane.
That's why the moon is stationary. That's why the moon. That's why we observe the moon as always facing us.
Facing us. That's interesting.
Right.
Charles says that's where.
There you go. Exactly.
Escapes.
That's my other point. You just reminded me of another point I needed to make.
Okay.
And that's it. You just did it. It's always reflecting the bottom of the planet there, and it's the same side. It's not two sides. You got that correct, Noel.
Charles says that's where light escapes. The aurora borealis effect begins there as well.
That's another supporting fact here of that theory.
Interesting. No, that's interesting. I've never heard that before.
The poles. Well,
I've always that's always been a great mystery to me, specifically like. Yeah, so the moon is perfectly tied to our Earth in a very specific ratio that is beneficial to both of us at the same time. It's always facing us, and it's like these 1 in like 1/100000th of a chance of it happening. Like, what? No. Like, how did that happen?
What's crazy about it is it doesn't require any power.
I guess the mainstream consensus is it just didn't suit my my curiosity enough as an answer, a well-suited answer for that question. Like, the particles from a collision over time gathered into a moon, and just the right specific consequence or circumstances led to this beneficial relationship. It just seems a little too convenient.
It gets me excited enough to want to build this and go explore myself.
Right? Yeah,
all
like
these different concepts. Like, I want to go see it for myself. Like,
we deserve to go out in space. Yeah, like us as humans. That's the final frontier for us. It's not just for rich people who can afford to buy Elon Musk's luxury bus to the moon or to the Mars. Like, we all deserve to go and explore space and see the universe with our own eyes. And I'll be damned if the rich people keep us from doing that, for sure.
Listen, I'll always promote this kind of science and research because it gives hope for our future generations. Because if we cap them, then hope dies and then they become bums. But if, we constantly give them that, then they have a drive to,
yeah, but you'll never get to the angle of the moon to see the moon at that angle.
Listen, I know if I keep on pursuing this, at one point, even if I'm an old lady, but it will happen in my lifetime. you know. So, you know,
Yeah, I think
it's something that
things are
They
happening
say you
fast.
can't even see the sun from space.
But
Mike Faraday said
things
that.
are changing fast regarding our technology and disclosure, specifically. And you know what? Professor Richard Wolff says, a professor of economics emeritus. He's very brilliant, and he says, you know, change. It happens gradually and then all of a sudden. So, there's a story about this political leader, and he was, talking to his political volunteers, and they were complaining, oh, the people, they're unhappy, they're angry, but they don't want to do anything. And he looked at them and he says, it's true. For decades, nothing happens. And then in a few weeks, decades happen. And that's how it happens. You expect change to happen. It's, slowly pushing and pulling one way or the other for a while. And then all of a sudden,
a burst of life, like evolution. It took forever to reach a point, and then all of a sudden,
like a
You
pulse,
think the
like
ancient
the
Greeks
tide.
and Romans, they all fought wars with illusions and created the projections of their ships over there.
Oh, you have something up here. Let me pull it up. I wasn't even looking.
And they don't require power. They just require, reflective dish and sunlight.
Yeah, just the refraction and reflection of the light, utilized in a very, very smart way.
It's almost unbelievable. I mean, then you think about magicians, how they do their tricks.
Yeah,
When you see this, it's like,
as much as I like magic, I hate magicians now because they just piss me off. I don't know how they're doing some of the stuff they're doing now.
they're opportunists, they make the money where they can. If they can entertain you with something like that, they will.
Yeah, you're right about that.
Have you ever been to like Holland or like Europe?
No, I haven't, but we plan on going eventually.
Yeah, it was like Holland in particular. They got a lot of street performers that do magic.
That is so cool.
And they're good. And they fool me, even though it's amazing what they do. And they must be getting somebody to play along because they'll even hypnotize people right in front of you. Like,
there's an expedition that takes
Amsterdam.
a U-boat from Russia's side all the way to the North Pole, but it only happens in July, and 100 scientists, 100 individuals can, be on that U-boat because the U-boat is a nuclear engine that can crack through that ice, up in the North Pole. They do it in the month of July. It's just this, there's a gap in time where every 4 years in July, I don't know if it has to do with something with leap year or this or that, but that particular month every 4 years is the only time that they could take this U-boat and crack through the ice, because the ice is the softest at that time, and where the sun is projecting its energy, in that area. So
that screw is so impressive. Sorry.
Right. It's what the hell, man. It's like you can't even freaking believe it. It's like you see it, you still don't believe it.
In Albuquerque, and I met this individual. He's a scientist that was the engineer of one of the first rovers on Mars, and he has a bunch of books. It's called the Be Earth trilogy, and he talks about a lot of things that scientific things from his perspective as an engineer that engineered rover car or whatever the thing that on Mars,
the Mars rover.
And he's got a company called Eve Fleets, and it's he manufactured this type of truck that is good for transportation within an industrial or a manufacturing complex. He produces the type of kind of cars. But he's done this trip twice, every like 4 years. They gather like 100 scientists and a few people as reporters to take this and do the measurements up on the North Pole. All the different anomalies, but all their different devices. And this is a collaboration, a scientific collaboration all across the planet. And there's no political constraints on that, but the access to it, that you really have to be a true scientist, with the accreditation.
Yeah, I know it's restricted there. It's very restricted.
I happened to, get all of this. I made a phone call. I searched after I heard about Admiral E. Byrd and his story.
Yeah.
I thought it would be kind of cool in our modern day. Is there an expedition?
Mm-hmm.
So I searched it. A phone number, came up. I dialed that phone number, and this individual on the other side of the line picks up. And I was telling him, hey, I'm like interested in your expedition trip, and all of this. And he's like, well, we do. He explained to me all of what they do and everything. And then he asked me, where did you get this number? I'm like, well, I found it on, search it. Like, I just searched for expeditions.
Yeah.
And it turns out to be, he's one of the, he's Trump's best friend, Yeah. On top of it, the day that I called him was they were doing the inauguration.
Wow.
And he was getting dressed, and he's like, he was talking to me while he was getting dressed. Then he tells me, you're going to see me on
Trump
TV.
was talking?
And I'm like, what do you mean I'm going to see you on TV? He was like, well, I'm here for my best friend's inauguration, live. I will be in this row. I'm wearing this clothes, blah, blah, blah. So, cameras go live, and I'm looking, behind Trump, and while he's talking, and exactly.
No shit.
Wow.
Yeah.
That's a cool story.
Cool.
Yeah, I met very interesting people in my life, just because I ask questions, and and I just what's gonna happen,
Right,
what's the
for
worst?
sure. Never stop asking questions. The best thing you can instill in children is curiosity, and that's something that I learned to be curious about, because curiosity it drives you. It drives you to want to find the answers.
Yeah. So the next trip that they go to the North Pole, I already have earned my seat between those 100 people. So whenever they decided, I've already sent in, my 4 years ago, my passport, pictures for everything, so I can
cool.
Yeah, because you have to get clearance from your residing nation, wherever yours, and to Russia. So Russia still has to give you clearance too.
Wow.
They need but it's I'm waiting for that.
I'm sure you'll get it. Yeah, that'll be exciting, and definitely keep me updated on that. We'll have to do an interview or something when you get back.
Yeah, they do this.
Ben's not going to the North Pole.
They do this conference and it's called.
I'd love to go, man. I'm gonna get the really thick jacket though.
I had the time of my life.
I mean, I would go if somebody invited me. I would probably go. But,
it's dangerous to go out there.
It is dangerous. I'd want to bring some protection against polar bears for sure.
And you got to go on a boat too. That's the most dangerous.
Yeah, I don't like riding on boats.
Boat is it's the biggest.
I don't like floating on the boat.
Planet Earth.
You said what now?
That's because our aircraft technology is not that reliable. Boats are more reliable than the aircraft.
It has satellite telecommunication on the boat. Like, you could do live webcasts from the boat globally.
Oh yeah, they're more advanced now. That's for sure.
Yeah, we'll probably turn it into a cruise, a party liner. We'll go rock that boat.
This is a military boat, guys. This is not a fun boat. This is like hardcore, the highest tech of communication anywhere. And towers and
Look at the detail on that.
And they have like a helicopter for, you know, emergencies on the boat.
Yeah, no, that's a really good feature. That would make me feel a lot safer going to the North Pole with a helicopter on the boat.
Yeah.
So I'm wondering, this principle is just based off of the geometry of the mirrors inside, right? So
Yeah.
I'm wondering if we can recreate
The degrees.
If we can have a computer with a screen somehow recreate an object.
Well, you notice how the top of portion of it vanishes when you get
it's
to
a
a
very
certain angle.
it's very restricted.
That's only when you still look at it from a certain angle, because
And remember, the new technology does the 360 animation, so it wouldn't work with some of the 360.
Right. But if that hole was perfectly 180 degrees concave, which it's not, it's like 240 degrees concave.
Right,
So
it's not completely spherical.
Right. And who's to say if it wasn't 180 degrees concave, how much higher would that project? And would any of it clip off? It would all be there. Because you can't lean down more than 180 degrees to look at something before if you go to 181 degrees, you're already below the floor 1 degrees. Because, you know, horizontal is a 180 degrees. The top portion of the horizontal plane is a half circle.
You got to put that reflection under a microscope and see what shape, like how do the gradients reflect.
You know, and try to imagine how deep is the middle Earth hole. It's probably a couple miles. So whatever it projects would go that high in the sky.
Yeah, you've given me a lot to think about.
A couple miles deep.
For sure.
And inside the hole, it's probably a bigger hole in there. It's like you got a smaller opening at the top, just like here. And it's probably the same kind of setup, but not 220 degrees concave, but 180 degrees or even less. 90 degrees.
What if you put it on a small Lazy Susan and have something from the bottom rotating it? It would look like it's rotating.
Yeah.
And so, like, the 360 could be achievable.
Or if the light source is rotating around it and the person viewing upwards is stationary.
Like, you see that little thing that you have on the side, the ones that they use for the center of fidget spinners, you know, that little, yeah. Well, if you put that, wouldn't that rotate it? There you go.
I mean, it's not there though. It's down further. That's crazy. Well, the leaf is real, and the real leaf is being projected upwards. So, whatever's at the bottom of the middle Earth hole has a light source going around, and that's our sun. And whatever's at the bottom is going to be projected upwards. If the hole is not concave and it's jagged and it's full of mountains, and let's say at the top of those mountains there's a bunch of fog, and that's water, and that would create a reflective surface just like you see here.
I mean, with this it's such a
simple... Up would be another layer of clouds.
It's such a simple scientific principle. It's hard to imagine that nobody has cracked holographic technology yet. You know, like why haven't we seen this?
It's probably the most under-researched
yeah
there is.
optics.
People like to be amazed, but not no, they don't care on how it happens. They just like to be amazed. That's all.
Right.
That's true.
You know.
Yeah.
It's too much think power. It burns your brain out. It does. You try to figure it out, and you can't understand why the visual is so accurate.
It's like when I'm trying to explain something scientific to my mom, and she goes, "I don't care. I just want to know that it works." You know, it's like all right.
Yeah, and that, I mean, honestly, I try not to judge people, but that kind of lazy mentality is why we have people who aren't curious.
It's not, I don't think they're curious. I think it's just people become so busy with their routine life that these subjects, you know, take time into understanding. It's a knowledge built. It's not just an immediate thing you understand. It takes many hours, countless, you know, amounts
That's
of
true.
hours.
It's very tedious, time consuming, and most people don't have time to do that. That is very true.
So, you know, you just have to, you know, I try to do it in between life, you know, where.
My brain's always worked different than most people, I guess. Like I just I'm always engaged. My thoughts are always like running. I can never stop questioning what's going on around me. So I don't know. I tend to have an anxious personality, if that makes any sense.
You could tell scientifically if your neural brain waves oscillate faster than the normal person, it means you're more of a person that like is a thinker, because you know they're always firing up. So you always have a thought in your mind. You know, it's not just like normal brainwave where it's not really registering active thinking. Rather, it's like a subconscious, you know, wave function that to run the biological system. So that's one indicator. You know, on measuring, like, you know, for me, I think my neurons are always like, you know, blasting. To drown out, I sometimes listen to techno music so I don't hear my own thoughts.
Yes, yeah, I do the same thing. That's so weird. Yeah, I blast EDM, or not EDM, trance. I blast trance music, 90s trance.
Yeah, just so I could relax, you know.
Right, yeah, to drown it out.
Yeah.
No, that's cool. I guess we all have a lot in common here. So, no, it's really cool that I got some people that I can relate to, I guess.
Scientifically, your frontal brain cortex is active. You know, that's like when they measure it, that's the region that they check for. If that, you know, it's the frontal cortex. Once that, because your visual cortex is tied into the frontal, you know, brain cortex. So your brain is giving signals to your visual cord, which is altering, you know, your vision perception to match the frequency of your brain wave.
Yeah, it's all about frequency, and isn't the brain just a giant generating a giant magnet?
Yeah, yes, it's constantly absorbing information from the universe. We're living antennas.
Probably through some form of inductance. I would assume the same kind of like 0-point inductance that this coil is using.
Maybe.
Yeah. I know we were reading about cold electricity, and that seems to be, in my opinion, it seems to align with my theory that, you know, constricting one of the poles on a magnet will produce an excess of radiant energy.
Holy shit.
And that'll just get absorbed
It's
into
a hologram.
anything. Oh, wow.
Hey, that's a real life hologram.
That is so pretty.
How the hell did they do that?
I don't know. I know they're doing some crazy things with drones, like swarms of drones.
This is in Dubai. This is in Dubai. I heard about this. They got hologram tech out there running already. There you have it right there, I guess. Looks like that's the real hologram from a cell phone. Or is that the
What's projecting
CGI
it?
again?
It might be a CGI.
Yeah. You think so?
It might be. I'm always a little skeptical because
it says it's a hologram from Dubai.
And CGI has gotten so good, like computer graphics have gotten so good that
Wait, holographic fan.
a lot of people like amateurs can just whip something up, but you know, I'm not too well versed in special effects to give an opinion on whether something's real or not.
No way. Look at this. This is a fan that makes holograms.
Oh, that's cool.
With LED beams. The fan's
it's spinning
too
right?
fast.
Yeah.
Yeah. That's cool.
Yeah, I like that.
Just that looks so real. Maybe that's how they did the I don't know. Crazy. That's so detailed.
I like the vibrant colors too. It's like popping.
It looks like floating plasma waves.
Seriously,
right?
Hologram.
Yeah.
Oh, that's neat.
That's what I was talking about. That's like a do-it-yourself thing, you know, like it's cool. There's like special videos that you know, you play and you could see these like things.
Yeah, it looks like it's operating off of the same scientific principle, right? Of refraction.
Yeah, but this is using the cell phone, not an object.
What the hell?
A 2D. Okay. Yeah. Huh.
I'm
going to take a quick temperature test for the system here. I might charge my headphones for a few minutes as well.
You know, motions in, you know, particular area of the feet, you know, around the object, it would rotate the object. You know, like like let's say that that hologram is in front of me and I want to enlarge it. My hand motion of like holding my two hands and enlarging it, like spreading them like my hands apart would enlarge the hologram image, but it's like programmed through the motion of my hand. Yeah, just like that.
Right. Just like we do with the phones, but just
Yeah.
it reads your motion of your hand.
Yes.
Just like sign language. Yeah, the computers can read all of that and convert it to instruction set. Any symbol you give it, you can have it understand that symbol as a certain set of instructions or definition or whatever. Yeah, but that Amazon toy requires no power at all. That's the most amazing thing about it to me. It just works off the mirror technology and interesting stuff. So these magicians are doing the same thing, like was it David Copperfield? He made the Statue of Liberty disappear. He probably just projected what was behind it in front of it with some concave projecting equipment, some kind.
How big though would he have had to have that equipment? It would have been like a big size piece of equipment to do that reflection.
I mean, like with a regular lens, it can take a small object and magnify it so that you can see it big, right?
Yeah.
So this here is a lens technology. All you do is reshape the angle of the concaveness, change the angle of it to change the size of the object being reflected. Something like that.
Yeah, but let's say you're saying like where would the audience be in what layer?
Well, David Copperfield knew where the audience would be, and he knew where he would have the cameras, where the cameras would be filming from.
Yeah.
So he could have set the projector up so that it would appear at anybody from that angle, view angle, from that perspective. But if you were like, let's say, watching the show from your apartment miles away with the binoculars, you'd be at a different angle and you might see half the Statue of Liberty disappear. Instead of the whole thing.
I get it, like how when the alignment of Earth and the Moon, sometimes we see.
Yeah, we ourselves have no idea how hologram technology works, but believe me, a strong, steadfast magician, that's the first thing he looks into. Is how to create holograms. That's probably the primary research for any magician. They know that holograms work, but they wouldn't just stop there to perform their tricks. They would learn every detail about the science. We don't know enough to really.
There's a new material called utility fog, and it creates like it tracks the light where a person, if they walked through this utility fog, they disappear. Like they like an invisible cloaking method.
It disappear to the human eye, or?
Yeah, to the human eye. Of course, I believe it could still be detected with sensors, but for the human eye, it becomes invisible.
Yeah.
Utility fog, nanotechnology.
we cannot see infrared, so there's other spectrums we can't see either. Yeah, there's a lot of light spectrums and frequency spectrums that are in the light bandwidth of frequencies.
I have an infrared and an IR, like night vision goggle, like like scope.
Is that a
You know, that light band frequency, but it's like a handheld one. Like I could see with it like completely 100% dark, and it's a green room. Feels like it's like a.
I've never had a chance to use one of those things, but they work well here.
I bought it like off of Amazon. It was like maybe $30-$40, something like that.
That's it? Wow.
Yeah. Yeah. It wasn't.
They got a lot cheaper. Well, it's probably an average unit. It's not like high definition or nothing.
I believe they use it to for they're in the woods for animals to see if there's animals around, like things
Hunting,
like that.
Okay.
Yeah. But
it'd be good enough to pick up something, that's for sure. A lot more than what your eye can't see. You can't see any of the infrared.
Absolutely. Very, very cool thing.
It's so strange though how just because there's an object in front of you that's emitting infrared light that you can't see, but at the same time it seems to be projecting what's behind it as well. Because if it wasn't, you would see a hole in the space you're looking at where this object was emitting infrared. You would see a gap, like a tear in space. But you don't. You see what exists behind the object that's projecting the infrared.
I want to get one of these toys. This looks really cool.
Yeah, I bought this thing like 3 times. I gave 2 away as gifts. The first time I bought it, it was like $10. Second time I bought it, it was $12. The third time I bought it, it was $8. So I don't know. They changed it. Amazon sells a lot of these, I think.
I'll look it up. There's another cool one where things levitate, like it's a rotating magnet, but through magnets, like they put little objects and they just float. So like 2 platforms, the magnetic, and there's like space between them, but some of them are like night lamps and very cool, like little things.
Yeah, no, I just bought this thing to verify. I mean, I'd never seen a hologram before I bought this thing. And I was just searching for a hologram kit is what I was looking for. And this came up. And I said, whoa, you mean I don't have to build one? I could just buy it. I was like, I was so satisfied. A lot of work.
LED lights around the circumference of it, what would it look like?
Well, it'd be more accurate, I think, because you'd be, it would work in the dark. You wouldn't need sunlight. And because if you shine a light at it with your hand, move your hand around with the light, you can sort of see the hologram move a little bit. So that's why I say the moon is a hologram, because the sun is going around the middle Earth hole, and the reflection at the bottom of that hole is being moved around by the movement of the sun going around the hole, because it's the angle that the light enters the hole. The reflection, the hologram exits that hole at a 90 degrees out of the hole. So the light comes in the hole at 90 degrees and reflects out of the hole at 90 degrees. But it does that in a 3-dimensional 90 degrees. So a cone, a bunch of 90 degrees all lined up in a cone. but not a full cone because the light coming down into the hole is coming down at a angle of about 90 degrees as well. You're not getting the full 190, well, you might get 180 degrees of sunlight into the hole because the hole is a 360-degree hole. So it has more than 180 degrees. But the sun is not directly over the hole, so you're not getting 360 degrees of sunlight into a 360-degree hole. The sun is rotating around the hole from the sides at an angle, and that's why the moon is so high up. It doesn't change its height. Because the sun is the same height as the moon. And that's why, because the sunlight goes in the hole from that high up and at that angle, and it reflects back up at the same angle and the same height as the light source.
Interesting theory, but I would hope not. I would hope that the moon is real and the sun is
And
real.
what difference does it make if the moon is real or not? I mean, they say it creates the tides, but
it makes a difference. It means that we have been
what?
deceived, you know. And
Why?
now
Why, if the moon is a hologram, why does that eliminate its effect on the tides? Who's
it
to
does
say that a
not.
holographic image
It doesn't eliminate
cannot affect the tides?
the hope of exploration in the outer space. That's what it like. It affects. It doesn't affect the effect, but affects the
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 moon doesn't, but the moon
fire
doesn't represent the entirety of outer space. It just represents a
sky.
hologram that's occurring here on Earth.
We absorb hope.
Between,
I mean, it's a natural human response to
I guess,
like you
I
don't
still think the moon is
fly,
beautiful and it
you
represents everything
know,
you
you
want
look
it
at the
to.
sky and it's like you inhale life, you inhale possibilities. And if you all of a sudden like you figure out that everything that you're seeing in that image is a fake, he's just like
Right.
like yeah.
But also transmit the energy of that ground of that whatever in the hole. It will it'll like a carrier wave. It'll bring the energy of that surface up into the sky, and therefore, it has mass because it's light, so it can also impact gravity on Earth from up above. The actual hologram, I'm saying, can create a gravitational effect on the planet because it's a light source. And light is the source of gravity. In my opinion, I think light has everything to do with gravity and time.
Time
That's just my opinion.
but I don't. I think light gets affected by gravity, but gravity has nothing to do with like
But light creates mass, and mass is all you need for gravity.
like light bends when there's a strong gravity. It bends towards it, so it gets affected by dense objects. But the dense objects don't become more dense because light is being bent towards their unless they're stealing energy and creating their density. Maybe you're onto something.
I'm just saying, light has mass, and if you can focus it enough, you can focus the mass, and therefore simulate gravity. because the light is creating a certain, resonant flow of a movement that establishes I don't know if it's a magnetic field, but it definitely establishes a force. The light does. You feel it when it hits your skin, it's got a lot of force to it. You can't stay out in the sun too long. It's just light though, huh? But it still burns you. At first it feels awesome, It's the best light you ever had. It doesn't burn or nothing. But you're out there for more than an hour, all of a sudden you're running to get away from it. Explain that one.
I'm from Florida, so I know all about running away from the sun.
Yeah.
Where are you guys in Florida?
I don't live there anymore, but I was from West Palm Beach. I grew up there.
Mike, where are you located in Florida?
South, like Miami and Miami mostly. I've been all over Florida. I grew up on, like Miami Beach and Miami.
How far is Fort Lauderdale from Miami?
30, 40-minute drive, depending on traffic. Maybe 50 minutes.
I was planning a trip to Fort Lauderdale soon.
Yeah. Work related?
No, taking the kids beach vacation.
Oh.
Yeah.
Yeah, I grew up. I did a lot of beaching when I was young.
I've been to Miami twice. It's not a family oriented beach, but
It's a tourist beach.
Yeah.
A lot of tourists.
Yeah, but Fort Lauderdale is more like, for younger kids and things like that. It's not as condensed, not as.
Check out Golden Beach on A1A. It's not far from there. It's a very private area. Probably hard. It's hard to get in there sometimes. I mean, it used to be easy, but it's still you still get in there. There's parking areas. I think I don't know if it's more controlled now, but they started to control those beaches a little bit. We used to go there because nobody would go there. But they're like really rich homes out there, so they probably started, proprietizing the beaches over there. As soon as you get to like West Palm, though, it's plenty of beach and a lot of, most of the people are packing in on the beaches on the around, all of, Fort Lauderdale all the way down to Key West.
Yeah, I was looking up there. There's a bunch of all-inclusive resorts where they have their own beach,
Yeah.
So I don't know. I'm still looking through different ones because a lot of them have a road in front of the hotel, so you have to cross a street to get to a beach. But there are a few that are
Key West is interesting.
Directly on the beach, ocean front. Not ocean view means there's a road. Ocean front, that means it's right on the beach.
If you ever go to Key West, don't go there on a weekend because it's so trafficy. But does everybody likes to go there?
West to Highway number 1. I will never do it again. It was the most not fun trip,
Yeah, it's a long road.
Not only that, man. It's everybody that's on there, they're party poopers. They're all military, They're all the
drunk drivers.
Yeah, they're not normal. You feel like the service people, the hostess or at the bars or at the anything, you feel like the people are so mechanical. And I asked wait, why? Oh, they're all Marines or they're all in the army. They're all Marines pretty much. So that's an extra job. So they
because I think the Homestead Air Force Base.
Exactly, but they're not fun people. Like they're, like the whole town like lame, and I don't know. I didn't have that much fun.
No, the Air Force people are like, the only time they're fun is in the rec room when they're playing pool and right after eat. After that, it's attention all the time.
Exactly.
I've been to the Homestead Air Force Base. I used to be a Boy Scout member for 10 years, and we went there like twice by bicycle, 15-mile ride, on the bike, there and back each way, 100 miles.
I drove, from the Keys all the way to Miami. It was like, it was a fun drive.
You can drive on bicycle from um, um, Miami to Homestead Air Force Base. It's 50 miles. Take you the whole day. And yeah, did that twice. And if you can get in there and you're in the Scouts or something like that, they'll let you in. And the steaks are 5 cents. A 16-ounce steak.
Where is this?
The Air Force Base.
Oh, the Air Force Base. Okay.
Any of the Air Force bases. If you're in the Air Force or you're in the military base or whatever, all those bases, if you're in the Corps or whatever, you go to the rec room to get food, a 16-ounce steak will cost you 5 cents. And an orange juice will cost you 5 cents. Everything's 5 cents. It's nuts.
They need a lot of nickel.
Yeah, you get a full course meal for like 20 cents. It's like that. So it's kind of like communism. I don't know, man. Socialism.
Maybe like I think they're trying to give it a monetary value, but not, nothing significant.
Well, I don't know. When you think about it, the military people and these organizations, they own a lot of land and they have a lot of cows and a lot of food. They do a lot of farming, so.
Never thought of that, but yeah, you're right.
And the government owns co-ops, all that. That's the only reason why our country's successful, and it will always be as long as we continue to do the farming thing. They'll never be able to take us down, no matter what communist regime you have out there that's trying to oppress the free market. And the free market exists because we farm it, we create it, we make the produce, the food to put on the market. People, they are concerned, that's where their money goes, to food and resources. It's our primary use for money. And
it's for control. Because you could be a billionaire and have $100 billion in your account, but somebody at a click of a button can freeze all that because you're not going to have it, in your hand. You're going to have it in a banking system that is still controlled by, whoever controls the money.
Well, that's the banks.
Yeah,
banking, fractional banking.
So you're absolutely right. The real value is land and natural resources. Then you have control. It has a hierarchy over, it dictates what the value of money is. So yeah, real money is land, is cows, is plants, is farming. That's real money. The paper stuff is just to transact these natural resources, from one place to another to give it a value that, you could buy other things with the whatever allocated value. Like for example, a cow is like $2,000. Okay, it equals like this amount of pounds of meat. And there's a value set.
Yeah, but the cow's price changes with distance. So
Yeah.
a cow in one country is, if you're in that country, it's cheaper for you there because they can get you the cow easier.
Yeah, because
it's not you can come get it.
It's a natural resource. We think of natural resources, things that just come from underneath the ground, but no, livestock is a natural resource. And so, that is the more tended to your livestock in your country, the more you're going to populate of that, and it's for your people. And if you have saturation, then exportation would be the second option. But you have to saturate your natural resources to your population first, and then when you have excess, then that becomes the exportable good from your country, because you might be feeding your cows like top grass. In another country they might be feeding.
Yeah, if you notice, Brazil and other countries, they're in a competition to create more grazing land for cows. McDonald's is buying a bunch of up the rainforest for that.
Not every cow has the same, meat.
You don't need to do that. You don't need to clear the land to have cows. Cows need shade. They get grass around the trees. They don't need open. They just do that because they can crop all the grass and feed all the cows in one spot indoors. They can cut all the grass and bring the grass to the cows. That's why they cut all the trees down and make open fields for growing grass for feeding the cows.
Some meats, when you buy it, it says like it's a, like it's a free range, like it's fed naturally, not fed synthetically.
Yeah, but the Amazon farmers, they're not doing free range the way we are. They're cutting every single tree down. We have trees in our pastures. We don't clear the land like that. They're just greedy over there in South America. They want more money, so they make more grass and more cows. They're in a competition with other cow meat producers like the US, the North Americans, and the Europeans. It's a competition who can create more meat, and so they think they can do it by killing all the trees and leaving more room for grass to grow because there's more sunlight hitting the ground. And that means more cows in the end run to them, That's not the right way to do it, in my opinion. You need some grass. You don't need all of it to be grass. Cows, they graze off of more than just grass. They graze off of clovers and stuff that grows in the shade. Shady areas. Clovers.
Like a variety in the animal's diet, creates better distribution of, hormones in that livestock, which makes it a healthier thing for human consumption.
Plus the cows, their manure is prime source of nitrogen for the plants all around.
Absolutely, it's fertile.
They really do fix the soil, no matter how screwed up it is. If you put a cow on an old put a few cows on, get rid of all, like let's say you take a smelting area where they were smelting metals, and you get rid of the smelting factory and clear the land there, but the land's all polluted with lead and iron and all kinds of metals from the smelting that was going on. You put a couple dozen cows there, and if there's no grass there in the start, the cows will migrate out to where there's grass. And if you keep the water there, they'll come back to where the water is, and they'll drop dew on the way to the water on that messed up land. And believe it or not, that dew will start growing grass right over that messed up land. And next thing you know, a special weed will come in to break down that toxin, the special, It's just amazing. Nature
Uh,
finds a way.
Buy a bunch of cows and transport them to, lands that have lost the,
Here in Florida, on the
their-
walls, if you don't maintain your walls, you get a
and
crack in your wall,
like rent them out. Like, yeah, I'm gonna rent you
you're
my
gonna
cow.
see a plant growing.
It's like I'm gonna rent you my cows like for like 6 months, till get your land up and running again, and then you take your cows and go to the next person. It's like,
I mean, you don't even need to do that.
or-
I mean, the cow will leave the toxic area and search for fresh plants to eat. But as long as you keep the water for it to drink in the damaged areas, it will defecate there eventually, and that's what you want, because it's going to bring seeds from far away in its defecation, as well as a bunch of plant growing materials.
I have a question. Why was there a relay from one transmission of this video to another? I kept on hearing like there's.
Oh, I'd have to mute it. I'm sorry. So the cow's manure is also ammonia. It's a chemical breakdown process, and it's a hydrogen fermentation process that will also purify the land through that process of breaking down the very toxins that are in there with the fermentation event. It's part of it, because there's always going to be more hydrogen in everywhere you go, and that's fermentation, hydrogen deposition, hydrogen, buildup of hydrogen, and removal of oxygen. That's what happens to a pile of grass when you let it break down. It gets saturated with hydrogen, which I think the pH goes up in the numbers when that happens, if I'm not mistaken. And that pH change detoxifies it just breaks down the toxins and the metals and all that. The pH shift will activate like all these enzymes in the ground and stuff. I'm pretty sure something like that's going on. So having the cow on the bad land, creating the pH shift, it just renews the land. The pigs do that too. That's why farmers use pigs and chickens, not just for the meat, but the chickens will eat all the bugs, keep your plants from being eaten up by bugs, so that you actually have a harvest. So you have to have birds. But if you have berries, then the birds will eat all your berries. So there's pros and cons to everything, but in crops, the birds will totally
Unfortunately, the new multimeter fuse just blew. I think it was because the capacitor might have gave out finally. I don't know. And the system is jumpy when it doesn't have a capacitor attached to it. Like I have to turn it up and then it just starts fast. It doesn't start slow. So I tried to turn it up a little bit, not knowing the capacitor might have been gone, and it just spiked and blew my fuse. But I got some new results, and it does appear that the peak resonant range is around 1,000 hertz. I tried 800, and we're getting a little bit less on 800 and around the same amount of loss on the opposite end of the spectrum, around 1,800 hertz.
Yeah, I've seen similar things.
Yeah, so it's all making sense, but unfortunately my meter fuse blew. So for future reference, guys, I will not be able to read current until my new fuses come here, and they're shipping from China. So I don't think they're gonna be here within the next week or so.
I mean, they've already shipped, but I'm hoping.
I think you could put a shunt across the a shunt. It's called a shunt.
I shouldn't. I shouldn't
Yeah,
do
it
that.
allows the high amperage.
Is it called a shunt
It's
because I
just
shouldn't do
it's like it's a thick bar of metal. It allows the maximum amperage to flow while allowing you to read it without blowing your meter.
Oh, okay. Yeah, maybe on the next
Something like
stream, maybe I don't know if we have time tomorrow. We'll go into that, and you can show me how to do that.
If you look up shunt, amp meter shunt,
I'm gonna need
I think
to
that's
learn how to open the thing up to replace the fuse, anyways. But I did buy a pack of fuses so we can do the fuse test to see what rating it actually blows at.
yeah. If you have the shunt hooked up, it won't blow your meter anymore. Because the high amps will go through the shunt and not your meter, but you'll still get a reading. But you're trying to read amps, so your meter becomes the shunt. That's the problem.
So once I have like a small car battery or whatever, a different power source, I don't think that's gonna be a problem though.
Here it is.
Because I'll be able to plug it into the 10 amp setting without it shorting out the system, you know?
I think, let me show you this. I think you should look at this. Hold on.
All right, for those who are watching, these are our new numbers. For the over unity, the gain is set at 26. And we're using square waveform.
This thing. You see that? That's just a metal bar. And it hooks up to the amp meter somehow. I can't remember. Yeah. I think it hooks up to the amp meter. Right. There you go. You see that?
Oh, give me 1 second. I'm going to tab into it. Yes.
That is. How do I bring this image up?
This on the screen for everybody.
That's it right there. So you see, that's how you hook up the shunt to the back of an analog amp meter. That protects the amp meter and allows you to get a clear reading without burning out your meters. You should be able to, let's see, DC power, plus and minus. It hooks up to the amp meter there, and yeah, so where it says plus and minus, that would be your, the plus would be your amps coming in, and the minus would be your amps going out. And you put the shunt in parallel with the meter, and you send your amps through the shunt to read it. And the meter won't blow because the shunt's hooked up. All the amps will go through the bar of metal. You see, that's how that works. The meter will still read the flow of amps, though.
No, that's cool. I might do that on the weaker multimeter.
I don't know if you could put your digital meter across that same 2 points. I think that would also work with just a shunt bar. I'm not sure. But this is the shunt bar hooked up to an analog meter. One of these guys. So you only this looks like a 50 amp meter. No. Ooh, is that 50 amps? Yeah. 50 amp meter. Let me see how details on this thing. Analog 50 amp shunt. Scale range DC 50 amps. So it can read up to 50 amps. Hey, stop it. Stop.
You got a dog?
Right. 50 amps, so that's not volts, that's just the amps. It's just going to tell you your current, how many, you're not going to be able to see half an amp very well on it, because it's a very small movement on the needle. But I think you could just take a piece of metal. I'm not sure what this material is. I don't know if it's just a piece of metal or if it's like a diode or what. I got to look into what a shunt really is. I've just used this before. That's all. Never really done the research. It looks like it's just a piece of metal. So of course the current's going to flow along that metal. But it looks like the voltmeter is connected in parallel with it.
How much does one of those cost?
$11.
Oh, that's not bad.
I think it's just the shunt though.
And it's reusable.
Wait.
It's not like a fuse that's gonna burn out.
No, it's a 50 amp analog amp panel meter. Current amp meter with a 75 millivolt shunt. So I don't know. I mean, I'm not too familiar with. I just know that the shunt protects your meters from burning out. And that's I know that's why they use it. I think. Pretty sure. Let me read the comments here. Got this for an extra ATX power supply. It works like it should. Built well and accurate. Came with the shunt as well. It didn't send a wire required, but also go figure out. These panel meters were tested and found to be functional properly. I don't know. I have a mix of 4 brands. Useful to measure 12-volt current from a SUV hitch connector to a trailer. That sounds like 5 amps of current at 12 volts, which is 50, 60 watts. Works nicely and seems accurate. No, yeah, so the shunt is used so that you can have the meter hooked up to it while you're putting a load, a heavy load.
That won't mess with the circuit for the milliamp setting.
Oh,
because the circuit's
let's see,
600
milliamp meter shunt. Let's see. 30 amp analog amp meter panel current. 50 amp. Milliamp meter. Let's try that. $500 milliamps. What do you need? You're not going over 500. You're doing like around 1 amp or less.
Yeah, I'd say.
0 to 50 milliamps.
Although
1
I
amp.
haven't monitored the amperage at the max gain.
It's the flyback that's burning out your meter. Oh, here you go. See how they're using the shunt here for a voltmeter?
Oh.
They're doing it because it protects the voltmeter from blowing out. Because you're going to send 50 amps not through the voltmeter, you're going to send it through the shunt. If you send 50 amps through that voltmeter, it'll blow out. So they send it through the shunt and connect the voltmeter to the shunt in parallel. Somehow the voltmeter still reads.
Huh. Oh, that's cool.
But the current's flowing through the piece of metal, you know, instead of the meter. So you could try that. I mean, see, right now you're sending the current through your meter to get a reading. Send the current, you know, into a piece of metal. You know, the two wires, the output.
Yeah.
Is it those two wires? Hook it up to a bar like this, and put your meter to the two ends of that bar, your amp meter.
And the two ends of this bar have to be separate pieces.
You should
of metal?
get the same milliamp reading, but the current won't be flowing through your.
Or is that one solid piece of metal? Or is that two separate pieces of metal at the end?
The thing about those digital amp meters is that you have to send it has a shunt inside of it. It should. If not, it'll blow out the fuse. So it's using the fuse as the shunt, your digital meter. So if your fuse is less than 500 milliamp fuse, it's going to blow, right?
Yeah, I think the meters are only rated for 10 amps. It's got a 10 amp and then a 600 milliamp setting, and then the other one has a 200. So it's
But when you set it on to read, what setting do you have it on?
the milliamp setting.
So then it's going to use a milliamp fuse?
Yes, because it has two. It's a double fuse multimeter. Like I said, it's
and
a really
that's,
good multimeter.
rated. That fuse is rated for what? 500 milliamps?
600.
600. So you're sending more than that through there and blowing the fuse.
Yeah, no, and it flashes red, and it did flash red before.
Next time you read, don't read on the milliamp settings anymore. Put it on the higher setting. What is the other setting again?
So there's two plugs.
Put it on the 1 amp setting. And it'll use the higher rated fuse.
See, that's the problem that I'm having. When I plug it into 10 milliamp setting, it shorts the whole system out, and the stereo shuts off.
And it shorts out the meter.
Yeah, it shorts out everything. Everything just shuts off. Or maybe the meter stays on.
Because you're sending because you're sending the whole amperage through the meter to get a reading. I understand.
Right. Yeah.
Right. And when the meter
was my theory.
No, you got it right. And when you're running the system through the meter to run the system to get the reading, you have to do that. You have to run the power through the meter to read it.
Exactly.
If you have it on the 10 milliamp setting, it's going to use a 10 milliamp fuse and it's going to blow because you're pushing more than that through there. So put it on the 1 amp setting and convert the digital dot to get your milliamp reading.
So you're saying keep it on. Hold on. You're saying
you don't need to buy a shunt or do any of that. Just put it on the 1 amp setting on the amp meter.
Like
that fuse is probably still good.
Connecting it to the plates?
Yeah, I'm saying his meter has more than one fuse in there because each amp, I don't know how many amp settings your meter has. Let me bring up his screen.
So pull up the HT118A from Kaiweets. That's what it is. It's got four connectors. So it's got a couple of different settings, and the 4 connectors split off into 2 fuses.
Show me your meter.
I don't know why my camera's not working. It's frozen or something.
No, on the computer, on the live stream here.
Yeah, I think my camera's frozen.
No, there you go.
We've been going at this like for almost 6 hours.
What's the model of the meter again?
It's a Kaiweets, Kaiweets.
Yeah.
HT118A.
8A. I see it.
And so it has a 10 amp and then a 600 milliamp fuse. And when I plug it into the 10 amp, it shorts out the stereo, but the 600 milliamp setting reads it just fine.
It sounds like Morse code.
It is a meter. I
Is
wonder when
it?
the meter burns out. Yeah, it's the fuse. Good to see you. Your shields against life's uncertainties. I like the name.
Which one is it, Ben, on the screen?
1 second. So the Kai Wheats is that is click yeah, click the first one, because the Amazon
This
that'll
one?
yeah, because it'll bring you to the selection for the different models. There's the A version, the E version, and I have both of those. They're just different rated fuses.
Don't get one with an app.
No, no. This one's kind of from what I read with all the reviews before I bought it. It's kind of idiot proof. It's really
got 3 sizes: 4,000 count, 6,000, and 20,000.
right. The different rated the different counts are different rated fuses. I have the 200 and the 600 milliamp version.
So which one are you on now? The 600?
Yeah, 600.
So it's this one here. Yeah, okay. And you're on the milliamp setting?
Yeah, I have it plugged into the bottom 2, which is the setting for the milliamps, the fuse.
Okay. And if you hook it up to the 10 amp port, you can't read anything.
Yeah, well, it shorts out the stereo and shuts off.
On the 10 amp
Yes.
side. Sorts out.
Yeah, it shorts out the stereo, or it overheats it. I'm not really sure what it's doing, but it's just shutting it down.
You should be connecting
Because you're using the
from
stereo
the black
as,
common to the 10 amp port.
as an energy, like a battery. Like you're using the stereo like a battery.
A power source, right? Correct. And
so
I don't know why my camera's frozen. Maybe it's like you said, we've been streaming for like 6 hours. All the RAM's full. We'll be ending the stream soon, so I need to get some sleep for Malcolm's class tomorrow. I am going to be doing some highlights from Malcolm's class tomorrow for those who weren't able to purchase a ticket to the Cosmic Summit. I'm not going to show you everything because I don't think I'm allowed to do that, but I'll show you some highlights.
Live stream.
Try hooking to the 10 amp port. I don't know why it was short everything else.
Yeah. Well, my theory was that it's expecting 10 amps on the return or whatever, and that's too much for the stereo. I think the stereo can only receive back 5 amps. I'm not really sure.
Well, your output coil, the positive side of it goes into the 10 amp red port.
Mm-hmm.
And you, I'm trying to remember here. To measure amps, you put your amp meter in series with the load. So your light bulb would get its positive from the black port, the common of your meter, and then it would ground the positive through its filament to create the light. It would send the positive. The positive would enter your meter through the red port, the 10 amp or the milliamp port.
So you're saying I need to move the multimeter to the light?
What I'm saying is you send your positive power, your load,
mm-hmm.
you have to load that coil, right?
Correct.
And you were loading it with a motor or something, or
Yeah.
right. So you load the
yeah.
coil with a motor, and the motor gets its power, its positive from the common port of the meter, and its negative is connected to the negative of the source. So the positive of your source is the secondary winding of that coil. One end of it is putting out a positive, the other end is putting out a negative.
Correct. Yes. So,
so the positive goes into the positive end of that coil goes into the milliamp red port of the milliamp section.
Mhm.
And it goes out the black port of the common into the light into the light, and then out of the light it goes to the negative. And that's how you channel through your meter and the load with that coil.
So okay, so that's all I
take
have
the-
to do is adjust the multimeter, and then I can probably use the 10 amp setting then.
The multimeter should be in the middle of the source and the load.
So right
Can
now,
you go back? Can you
right
go back
now,
to your
In
diagram
series, in the middle
and show
of
us
the
on
source
the
and the
diagram?
load.
Yeah.
Mike,
So
can you go back to the diagram that you drew earlier and point to where you would put the
Okay.
like the meter?
meter. So right now the multimeter is just the positive is hooked up to the positive output of the coil and the negative to the negative output. And that is also got two leads coming out to the breadboard. So that's right now. It sounds like I have to just adjust the multimeter's position.
You might have had it hooked up wrong, right? It's possible. I don't think anything would blow though if you hooked it up wrong. So I brought up the diagram again. Here it is. Let me bring it up here. Let's see here. Okay. There's the diagram again. So you can see the diagram?
Yes.
So your meter, if we just look at the coil here, the green and yellow would go, the yellow would be your positive. That would go into the red port of your amp meter, the milliamp red port. And out of the amp meter's ground port, common, you would connect your load, one side of your load, and the other side of your load would go to the negative of this coil, of the green. And whatever current this coil is producing will be sent through the meter to give you a reading. And the meter will be the load because it has a fuse, a 500 milliamp fuse to act as a load to give you the reading.
So you said the negative of the multimeter needs to be hooked up to the positive end of the LED.
Let me see if I can draw it in green. Is it coming up? Yeah, there it is. So the your yellow terminal of the coil. Let me see if I draw a meter here. Into the meter.
Yeah, my headphones died, so I might have to limit my... So wait, so you're saying just hook up the multimeter without the load? Because the meter is a load itself. So I can probably see if it'll work in the 10 amp there. Without, I don't know. I could try it. I'm gonna try the way that you said real quick. Yeah, I'm trying to see if it works. So it's shutting down when I plug it into the 10 amp on the input. But on the output, it's just it's not reading the current accurate. Like it's like 0.0001. Oh, so I turned it on with the multimeter already on, plugged into the 10 amp, and it turned on and it's running, but it's not picking up any current. And I know it's getting current because the fan's spinning.
Yeah, because you're on the 10 amp setting. You can't do it. It's too decimal. You have to be on the milliamp setting to see the reading because you're only putting in a couple hundred milliamps, right?
Right, and that's why what I assumed in the first place, but...
If you're on a 10 amp setting, you're going to see like 0.003. Probably.
Let's see. Yeah, it's not picking. It's 000, but yeah, it's just too small. I mean, I do have it.
Too small of an amp.
Yeah.
You got to use the milliamp port then.
Yeah. Yeah, that's what I figured. But it was worth a try.
But you know, with an analog meter, you can hook up a much heavier duty or shunt to it than what your fuse is rated for inside that meter. That way you can go over. The spikes won't damage it either. I don't know why the spikes. Well, you know, if you're running it while it's hooked up to the ammeter and it's spiking and flybacking, then it would definitely blow the fuse, even though you're not going over the 500 milliamps.
Is there two different types of connecting cords to the positive and negative? One reads amps, one reads milliamps?
I have a rectifier, yeah. Yeah. So I have a rectifier hooked up. Yes, the signal is rectified, but it's only rectified for the DC motor. Mine has a function button that switches between DC and AC. I mean, it has a little, symbol on it. It both. Like you can switch between the two, and I did notice that when you're reading DC as AC and vice versa, it's inaccurate. Well, there's a function button. Yeah. Yeah, because it says right on the screen DC, and then you push function and it says AC. Mm-hmm. Well, it's the meters before the rectifier, so it's not after the rectifier. Yeah. Yeah, no, it's I don't think it's a problem with the way I have the multimeter set up, honestly. Wait a minute. I'm looking closely. It does not read AC. Uh-huh. Look at the bottom right port where it says 1,000 volt and you see a straight line with dots. So wait, it can read DC and AC. You see it says 750 volts with a swivel line. The bottom right. Max 750 volts. Yes, I see it. That means you can maximum read 750 volts of AC. And then do that. Is that 1,000 DC? Comment of that port with the, yeah, this can handle a lot of voltage. But that's referring to the voltage ports, the red on the top right and the black on the bottom. Right, those are the only ones that have the true RMS feature. Right, that's going to read both AC 750 volts and DC 1,000 volts. Mm-hmm. That's cool. So you can read a DC spikes on this thing, which, but on the amp side, it looks like it's in the milliamps. It looks like it's DC only. I can't tell.
So
you see how the line is the resident of DC. No, because the milliamp symbol even has the wavy line for AC on the meter. So, and it wouldn't enable the function button to switch back and forth between them if it didn't work, I don't think. No, I did some research on this. I show it show. Yeah. No, I watched some guy hook it up before I bought it to a waveform generator and pump it full of high frequencies and tested it against other meters for accuracy, and this one's pretty accurate with high frequencies. If you keep blowing, you're pumping a little. You must be having little bursts of over 60.
It is. It was like a little burst, but I did turn it up a little bit, but it did flash. It was like a burst, like you said.
Yeah. Your meter can only handle 600 milliamps. Get an analog one that can handle like.
Well, I need an oscilloscope. You know, that's what I really need.
That's the best thing, but you know,
Yeah.
a 5-amp analog meter is a lot cheaper.
Yeah. But you know, eventually I have some more better, you know, testing equipment.
You don't have to. I wouldn't use your amp meter like that. You're gonna keep changing that fuse. You're lucky it has fuses.
Hey, you don't have to tell me. That's why I bought a whole pack of extra fuses just in case. But no, you're right. I gotta be careful.
I think my meter has a fuse also. It's a little pain in the ass to open. Yeah, they have fuses in there. Maybe a different digital multimeter with a 1-amp fuse instead of a 600 milliamp.
That is a good idea. I think that's a good idea.
Or even a 2-amp.
Something that'll read high frequencies though, at least 1K accurately. You know.
Is that why you got this one?
Yeah, because I needed to make sure it was gonna read the AC. You know, because a lot of multimeters aren't rated for high frequencies. You said what?
Some of these meters have built-in function generators, single generators. So check them out.
Really? Oh, that's cool. That's neat. No, that's funny you said that, because that's what one of Malcolm Bendel's predecessors just did recently at the conference. Showed a bunch of pictures of that she made on her oscilloscope from all the frequencies that are on the plasmoid unification model, specifically for time, which is really wild to think about time having a frequency. Yeah, same here. So there's this thing called stereographic projection, and because technically the shape of the shape of the torus that Marco Rodin wanted to map vortex math onto is a higher dimensional shape. So they use stereographic projection, which you can actually map a higher dimensional object onto a lower dimensional plane. If you look up on, and if you watch Divine Science, there's a chapter on it. It's very fascinating, and they show a demonstration using light and shadow, where you can actually take a 3D sphere and take the curves on the sphere and map it onto a two-dimensional plane by fixing the light at the top of the sphere. Yes, it's stereographic projection, so it's kind of like the same principle. Yeah, and you can like you can't really measure that curve like very easily on the surface of the sphere, but when you map it onto the plane, you can clearly see it, and measure it easy. the curves turn into straight lines and turn into a grid. There's a brief chapter on it in my documentary. It's very fascinating, how they did it with turning vortex math into this practical, design here. Yeah. Yeah, well, that's what this vortex coil is. It's a product of applying vortex math principles onto a toroid shape, and they wanted to do a torus instead of a traditional hypercube or hypersphere, because it was Marco's theory that that was the underlying dimensions or geometry of the universe itself. Mine too.
I sound like I got the art figured out.
Why is that?
I'm still learning that. That's like I'm in the beginning stages of that. I know a little bit of art, geometry, how to draw certain things. The perfect curve, I can draw a perfect curve between evenly spaced dots. I think most of us know that trick. But that's the limits of my art skills. So I mean, when you say hyperbolic, I can't even imagine what that looks like.
Yeah, yeah. Hard to visualize. Yeah. So you're talking about a hypercube. So from what I understand, like when you try to look at the hypercube, yeah, but it's like it's a little bit more interesting than that, because doesn't the shape change depending on which angle you're looking at it? So it's like, you try to spin the thing in three-dimensional space, but it's changing because it's in a higher dimension. You just can't quite get that angle because it's always shifting. Right. It's it's mind bending for sure. It's like how we try to visualize higher dimensions. I can't do that stuff. That's beyond me. Yeah, flat world like blew my mind when I watched it. Um but yeah, that I'm gonna end the stream here because we've been going on almost 7 hours at this. Um Great work, everybody. I really appreciate it. I appreciate you guys joining in. Um yeah, yeah, anytime, and I'll probably be going on again tomorrow. So If you guys. Yeah, so I'm usually not available on weekdays either. I took the day off though for Malcolm's class, but I will be streaming tomorrow, and anybody who wants to come on and join me is welcome. I don't have access to this what is it called? Stream. But yeah, I'm gonna end it at that. We had a great stream. Thank you everybody. Much love. Yep. Many blessings. Good night, everybody. Bye. I'm losing my voice.